All right. Thank you for being here for Aether Cosmology. Bring your own Brenner Comp night. Tonight we are going to read work from Michael Brenner on Quora Answers. He is according to his profile, an engineer that studied at Vienna University, and he seems to have a very broad, deep amount of knowledge on a wide variety of topics and answers a lot of questions regarding geocentrism, flat Earth, physics, quantum mechanics, and a bunch of other things. So tonight we just kind of said, everyone, go ahead and bring your own Brenner compilation, your own question and answer of Michael Brenner, and that's what we're gonna do. We're just gonna go ahead and read the Michael Brenner. So I'm going to go ahead and start here. I'm going to read this one, which is, as an engineer, how can you prove that the Earth is flat or round? So, it is amusing to read non-engineers so this is referencing the other answers to this question, so just for some context. It is amusing to read non-engineers like Hazelton, Clinton, Russell, EA opening their answers as it were an SNL skit. You don't have to be an engineer. That's the same as non-surgeons claiming that you don't need to be a surgeon to do heart transplant. You just cut out the old and plug in the new one. Done. As long as they're allowed to do it on paper only. That's of course not how it works, and we all know it. Problem is that none of the fathers of the heliocentric system were engineers, even by a long shot. They were mathematically trained theologians, or hold on one second. I think someone is hot mic in here. I think it's you, Elijah. All right, cool. Thank you. So, theologians, where was I? Theologians.
And as such had no qualms whatsoever to the hand ultimate energy bill run up by their universe over to the Lord God Pantocrator. Take it away.
As did Newton, even in his Principia, which therefore is a theological piece of scripture, not science. Einstein perfectly follows this tradition when he says, I assert that the cosmic religious experience is the strongest and noblest driving force behind scientific research. Wow, what a statement. And with this sermon hands the energy bill run up by his Brownian motion over to the prime mover. Newton's Lord God Pantocrator in Brownian motion macroscopic particles displace a viscous medium, which is the picture book example of dissipating energy through fiction, that is, turning useful energy into useless energy. Einstein's 1905 paper does not explain nor describe this phenomenon physically, but circumnavigates it with statistics, a method that has been adopted widely in the 20th century in order to escape the uncomfortable position of having to explain physics. They just calculate it. Now, contrary to what B. Hazelton and others here claim, geodesy and surveying does not take into account Earth's motion. They measure distances, and the distance from end to end of a flexible ruler of 1 meter length is the same straight or bent. Also, a surveyor does not go out and investigates the shape of the Earth. He goes out on the premise that the Earth is round and then interprets his measurements accordingly. But whereas everything theoretical like geometry and kinematic can be cheated the way Kepler cheated with the purely philosophical term areal velocity, nothing in physical reality comes with the unit meters squared per second. Dynamics. That is, motion of real masses cannot be cheated with. A frictionless suspended object on a merry-go-round will inexorably end up at the periphery. There is no way around that physics fact. And so, a frictionless suspended object anywhere else on the equator of a spinning sphere will move towards the equator. No two ways about it. Do we have such frictionless suspended objects? Yes, we have quantum locked objects. There's no, so yeah, this is a quantum locked object using magnetism. I believe that's super cooled materials for the magnetic effect. There is no way such an object can remain stationary over a spinning sphere. and as there is always a non-zero resultant acceleration vector pointing towards the equator. Axial centrifugal acceleration, a equals the angular velocity squared times r times the latitude equals the angular velocity squared times r times the cosine of a, versus radial gravitation acceleration, g equals gm over re squared. So here we go. Cosine of, let's see. So he's just explaining, so the centrifugal acceleration, how there's no way around it, essentially. Obviously, these two vectors do not align and therefore leave a resultant acceleration vector, i.e. a force per unit mass A equals Fm along the surface pointing towards the equator. A frictionless suspended object will react to the minutest of such forces, so no excuses here. And because these objects remain stationary if not told otherwise by giving them a shove, they remain stationary over a stationary surface, i.e. a stationary Earth. But we wouldn't have needed to wait for quantum locking to find that out. Foucault's pendulum, for the same reason, could not swing symmetrically over a spinning sphere, and in general, pendulums would not swing symmetrically if not positioned with great care, because this biased resultant force is always present. In other words, dynamics is the prime field of engineers, and the idea of a spinning Earth, as well as the entire solar system and the cosmos as a whole, is not engineered. That is, does not answer to engineering principles. That's why cosmology and everything related to space has been relocated into the field of mathematics, because math does not complain when someone cheats. On the contrary, it gladly goes along with it. String theory is built on the thinly disguised cheat called renormalization, where a mathematical train wreck is renormalized. That is, the wreckage is ignored, and one continues as if nothing happened. This is a luxury engineers simply do not have, and that is also the reason why physicists look down with condescension on engineers as locked in and almost disabled by their unnerving adherence to the empirical rules of physical reality. No one puts that better into words than Einstein himself. Physical concepts are free creations of the human mind and are not, however it may seem, uniquely determined by the external world. Well, engineering is uniquely determined by the external world, and therefore, if you want to learn anything about physical reality, ask an engineer and stay away from physicists. So there you go. That was kind of in line with what we were just talking about offline about making measurements.
He does highlight the dogma rather well.
He does. He does. So this one, I'm going to go ahead and read now. What is atmospheric pressure? So, atmospheric pressure, as generally taught, is a case study in violation of what is called domains of validity, and thus a case study in violation of fundamental physics principles. Newtonian mechanics is condensed matter physics. Atmosphere is thermodynamics of gases. These two domains have very little in common. Newton mechanics is the study of actions and reactions of individual bodies, whereas thermodynamics is the study of the collective behavior of a system. Let's see what is taught and go from there. So we have the gravitational force of a column of air, and and then we have one, what is that? ATM pressure at the surface.
1 atmosphere.
Thank you. 1 atmospheric pressure at the surface, so that'd be 1 bar, right? And then
14.8 psi. Yeah.
Yeah, I'm thinking in coffee terms, espresso terms. So, he's showing how they postulate atmospheric pressure. So, flaw number 1. It is said that atmospheric pressure is the result of a column of air weighing down on the surface. This means, of course, that if you add all the columns of air thus envisioned over every single square meter of Earth, you would get the volume of the atmosphere as well as its total weight. But columns erected radially over the surface of a sphere do not add up by far to the volume within the perimeter of the periphery. The columns of, let's say, a 100 kilometers height over every square meter of the Earth's surface add up. 5 times 10 to the 17th power meters cubed, or cubic meters, yet the volume of a 100 kilometer thick shell around the same sphere is 5 times 10 to the 19th cubic meters. That it's 100 times more than claimed. Where is that weight weighing down? Because the surface is already covered to 100% by the bottom end of the columns. The irony is that this model only adds up for an atmosphere over a flat surface. But try and tell it to someone who uses this model. That's crazy.
Totally.
That's a good one. So flaw number 2. A column is defined by 6 surfaces, 1 bottom, 4 sides, and 1 top. Weight is the sum of mass particles times acceleration per particle. Now, if the column is open on top, as is claimed, then all particles above the bottom area contribute to weight. Space has a non-zero density of 10 to the 6th mass particles per cubic meter, out to practically infinity, and gravity in principle also reaches out to infinity. So that way, if anything approaches infinite, certainly not 14.7 psi. Is that not negligible? I guess I really don't know. It's certainly would be worth doing the math on. So the easy way out is to simply, flaw number 3. The easy way out is to simply assume and write 0 kPa as is done in the image above, and call 0 pressure the end of the column in lieu of a lid. But 0 pressure in this Newtonian model means 0 weight, and that means 0 particles, which we have seen is not the case. In thermodynamics, it means 0 temperature, which is also not the case. Space still has plenty of particles at a non-zero temperature of 3K. So because there is no zero zone available, i.e. there's no true vacuum, there must be a well-defined demarcation of what constitutes the atmosphere and what not, because 14.7 psi is a very well-defined pressure. Flaw number 4. Newtonian minds cannot wrap their minds around the difference between weight of condensed matter and pressure of a gas. Weight is defined by mass and acceleration, independent of temperature and volume. Gas pressure is defined by temperature and number density, independent of mass. I always get the scuba tank argument, where there's obviously a difference between the weight of a full and an empty tank. Yes, of course, but you are measuring the weight of the condensed matter tank containing stuff. What stuff is irrelevant? But when you try to measure the weight of the oxygen from within the tank, you will find that it is impossible. You only get a pressure reading, and that is independent of the mass of the gas. It is dependent only on temperature. Cool it down to close to 0 Kelvin, and you will have a close to 0 reading, although the mass of the gas is far from close to 0. At exactly 0, you have a bunch of atoms laying around at the bottom, and you can weigh them like billiard balls. But then you don't have a gas anymore. That's a really interesting point as well. Flaw number 5. Nobody has ever measured the weight of anything while it is bouncing around. Imagine thousands of tennis balls bouncing around in a huge vacuum chamber, keeping an average distance of 6 meters. That is how far air molecules are apart relative to their size. Now try to... Wait, what? Oh, relative to their size.
He scaled up gas
Yeah,
density to a molecule size to a tennis ball.
Gotcha. Okay. Wow. That's a pretty massive size. Okay, or massive distance. So now try to measure the weight of the collective of all of them while they are bouncing. The only measurement you can take is where they hit a surface, but that measurement only reads the excitement of the tennis balls, not their weight, not their mass. The tennis balls are not weighing down on the floor of the chamber, and when you walk in among the bouncing tennis balls, you won't feel their weight, but only their excitement combined with the frequency of the hits. This empirical fact is enshrined in a law. Avogadro's law states that equal volumes of all gases at the same temperature and pressure have the same number of molecules. And that means pressure is independent of mass, and thus atmospheric pressure is independent of the mass of the constituent particles of the atmosphere, and thus unrelated to weight, and consequently unrelated to gravity.
I want to put that on a t-shirt.
Right.
Pressure is independent of mass.
Totally different domains. Yeah, that is a crucial flaw. I mean, that's like that they'll argue that to their grave too. Some of them. So flaw number 6. The notion that a free gas can weigh down on people or stuff is irrational and nonsensical. The air under your chin is weighing up, for instance, and the air next to your cheeks is weighing sideways, all of which is nonsense, of course, because it has nothing to do with weight. Mass, and thus weight, does not change with temperature. Pressure does. Look at how few atoms are pressing down on the guy at the top of the mountain. Lower pressure. Look at all the atoms pressing down on the guy at the bottom of the mountain. Higher pressure. Flaw number 7. The notion that freely bouncing gas particles can stack up weight, as is always claimed, what is written here in the image below, is simply nonsense. That's not how gases operate. The only aspect a gas particle can communicate is temperature. So if anything stacks up, it would be temperature. But in an adiabatic or adiabatic?
Adiabatic?
Adiabatic, thank you. In an adiabatic column of atmosphere, i.e., without external heating, the temperature is constant throughout. The top particle has the same kinetic energy as the bottom. T equals pH over pH is a constant. And that means the absence of the influence of gravity, which is a law of position. So these molecules contribute to the pressure at this altitude. This is the thing he's saying is bunk. And these molecules contribute to the pressure at this altitude. So it's just based on a misunderstanding. Literally just using the wrong domain of physics to apply a concept. In practice, that means what is in practice, that means what is above you is completely irrelevant. Build an airtight bunker around yourself, and you'll see that ambient pressure is unrelated to the column overhead. I can make your ambient pressure go away altogether just by cooling your space sufficiently. And on the other hand, I can exchange the particles with the same amount of 10 times heavier ones. As long as temperature is unchanged, you will experience the same pressure. Mass and weight and gravity have nothing whatsoever to do with gas pressure. Flaw number 8. A major blunder made regularly here on Quora is the citation of mechanical kinetic energy. Ke equals 0.5 mv squared. Mv... I don't know what that would be. MV. Mechanical kinetic energy.
I think that sounds more like an inertial calculation.
Okay, gotcha. So Ke equals 0.5 mv squared. This is classically wrong. Kinetic energy in gases is only a factor of temperature. Ke equals 3 over 2 kT. No mass, no gravity involved. K is energy content per degree Kelvin. When you hear the battle cry of Newtonians, where there is mass, there is gravity, keep calm and remember the moments when you were physically present yet felt totally irrelevant. That's what happens when gravity meets gas. Gravity is present but totally irrelevant. Gases don't care about gravity. Conclusion.
It's true. And I just wanted to jump in with an injection of a term like the ideal gas law. And the question is, which ones on the table are ideal gases? And the answer is almost all of them. And the ideal gas law has to do with the energy state of the particles themselves. That's why they're a gas. Their energy state is so high that they don't resemble the same physical characteristics as solid or liquid mass. As such, they expand until they hit a wall.
Mm.
Just like it says here, it's got nothing to do with gravity. The point is that if the space is there, it will expand to fill the space. And this is what they're talking about when they say that.
Thank you. Yeah, well said. I appreciate that. So, yeah, conclusion. Gravity, as conceptualized by Newton, is a God principle, and a God cannot be allowed to appear irrelevant in any circumstances. Theoretical physicists who try to squeeze gravity into every nook and cranny of physics, like quantum gravity, for instance, are victims of a Newtonian theology disguised as science. Newton saw gravity as the divine immensity, which is the omnipotent and omnipresent agency of the Creator in space. In his Principia, acknowledged as the founding paper of Western science, Newton lays down the theological foundation of a religion of gravity. Quote, "Without the design and dominion of an intelligent and powerful being, he rules all things, not as the world's soul, but as Lord of all. And because of his dominion, he is called Lord God Pantocrator, aka Gravity." Wow. I never heard that quote. That's crazy. If you accept gravity as a physical principle, as opposed to worshiping it as a theological one, you will also be able to accept its limited domain of validity. In a theological framework, gravity must be a force because it represents the omnipotent God as the prime mover, forcing himself upon matter as the emphatic regulative principle, a notion which underlies all of Newton's work. But if you can bring yourself to letting go of that theological premise, you will have way less problems to accept the empirical fact that gravity is not a force, simply because it does not answer to Newton's definition of what a force does. A force overcomes the inertia of mass, that is, God overcomes the reluctance of matter to get going. Free fall, though, does not need to overcome that intrinsic reluctance, because matter simply does not put up a resistance to falling. It does so voluntarily, at a rate independent of mass. So here's the old feather in the bowling ball in the vacuum, dropping at the same rate. Boom. Because the notion of voluntary action without, quote, God's active rule, i.e., gravity's active pulling, is still a heresy, the observation made here in the free fall experiment is explained by the active role of the Earth, which pulls things down without itself being pulled, and with just the right amount of force, so acceleration is always the same. What people who fall for this argument don't realize is that the Earth is thus attributed a special role, one of a stationary as well as anchored body, which is not free to fall. Otherwise, it would do so, even towards a feather. Now then, what is atmospheric pressure? Especially, what does it mean to have a pressure gradient? Before we can answer this question, we need to recap what compression means in gas physics, because it is too widespread a misconception that the atmosphere is compressed. At the core of nature, everything is about energy, and compression of a gas is the prime example of input of external energy, i.e., work done on a system, except for one process, the isovolumic process, which, as the name indicates, is a constant volume process. This already tells us that we are not talking about compression. Let's look at the gas equation. P equals kT times N over V. We see that the pressure increases when we let more particles, N, into a given volume V at a given temperature T. This does not require work, as the inertial energy does not increase. For the atmosphere, that means that the relation of height-dependent pressure, pH, and equally height-dependent number density remains constant. A volume at sea level and at the same volume at the top of Mount Everest have the same inertial energy content, kT, where K means energy per degree Kelvin and T the temperature in Kelvin. So pH over pH equals kT. In joules is constant, or in J is constant. Is that what's in J? I don't see J.
Yeah, joules.
Gotcha. Here it is fairly easy to visualize that the product of energy per Kelvin times Kelvin is energy, but it is not so easy to grasp that pressure per density is also energy. Ah, okay. Imagine this like A equals F over M, so Newton per kilogram, where for the same acceleration you need more Newton for more kilogram. Here you have more density for more pressure. Result is the same. I had dozens of rather fruitless conversations here on Quora already about the barometric reading on top and the bottom of hills, as if that is any consequence to the atmosphere. You cannot take the barometric reading out of the energy term and thinking you are making sense. You have to also read out the number density, and then you'll realize that nothing has changed from top to bottom. That would be the same as comparing only the mass of a truck and the mass of a bicycle while they are accelerating at the same rate, without stating that they employ vastly different forces to do so. As much as the constant acceleration is concerned, it does not make a difference if 1,000 newtons move 1,000 kilograms or 1 newton moves 1 kilogram. It's always 1 meter per second squared. A equals 1,000 newtons over 1,000 kilograms equals 1 newton over 1 kilogram equals 1 meter per second squared. If you would switch the guy sitting on the bicycle over to the truck, he would be overpowered, or the truck underpowered, and the guy would die. So it is with you moving up to the top of Mount Everest. Your lungs are not made for this, like the bicycle guy is not made for moving a truck. But that doesn't change the fact that nothing has changed for the thermodynamic state of the atmosphere. The atmosphere is not compressed. It is only distributed along a gradient without input of work. And that means if the atmosphere would be allowed to evenly distribute, the volume would not increase because it is not compressed to begin with. And that means, of course, the atmosphere must be contained. Otherwise, it would disappear, like all gases do that are allowed by leaving a door open. The energy content of a volume up high is identical with that low down. So if a volume low down would gladly invade available space, the volume up high would do so just as gladly. Now, thing is, the energy content up high is 100 times higher than down low. Thermosphere 2000 degrees Celsius, because of an inverse temperature gradient, and such an energy content will not hold back from invading available space. Containment, therefore, is a must. Like all theological frameworks, Newton's too is based mostly on rhetoric and pompous yet opaque equations. Where the equations serve as cups under which the coin is skillfully moved around so you never find it. This is particularly the case with the barometric formula, where mass is demonstrably introduced, but you never see when it disappears again. Yet disappear is a must, because we already have a law for that. Pretty low-res photo here. So we have P equals mass over volume equals NNAM was N is the number of moles?
Yeah, moles. That's the molecular
Molecules.
computation
Okay,
about
gotcha.
mass.
Then m is the mass of one molecule, k is Boltzmann's constant, r is gas constant. And so then if p approaching 0. So there you go. Here we see how mass is introduced via density, kilograms per meter cubed. But that is already flawed, as in thermodynamics only number density matters, n over meters cubed. So we know that mass at some point will cancel out. It's just a matter of staying attentive to spot the moment. The on-purpose opaque equation presented in the image here keeps mass optically to the very end, but only for looks, as potential energy, mgh, and kinetic energy, kt, both feature the same mass in a quotient, which means it disappears. What remains is the height dependency of both pressure and number density, and the velocity, which we already met as the excitement of the tennis balls. Result. As expected and as expressed in Avogadro's law, barometric pressure is independent of mass and thus independent of Newtonian gravity. Because his gravity can only attach itself to mass, what the barometric formula shows us is how a constant energy per unit volume is maintained over a pressure and density gradient of the atmosphere. What it also tells us that we have yet to think differently about gravity. Contrary to a widespread misconception, Newton was neither the first nor the only one to think about free fall. Free fall is one of the oldest and one of the most thoroughly investigated physical phenomena in the history of natural philosophy. And Aristotle and Leonardo understood way better than Newton what we are dealing with here. Aristotle understood the voluntary character of free fall. Bodies want to return to a state of rest from which they have been pried away. You have to invest energy to lift a body, but when you let go, the body returns so voluntarily that it gives all that invested energy back. This place of rest is not any place of rest. It is the ultimate rest. It is counter space to which space itself returns. This may sound like pure philosophy, but alas, it is the process that powers our electrified civilization. Oliver Heaviside and Charles Proteus Steinmetz translated Aristotelian wisdom into technology.
Aristotelian, would you believe?
Aristotelian. Ha, that's a new one for me. Thank you. Leonardo also understood that the mother of and origin of gravity is energy. He presented the hypermodern concept, as applied in induction physics today, of force and motion versus inertia and acceleration, which is practically the same notion of a body pried away from a position of rest by applying a force over a distance, equaling work, after which the body wants nothing more than to return to the place of inertia, giving back the invested energy. It is important to be aware that the notion of motion is not corresponding to Newton's laws of motion, which do not apply to gravity because of the voluntary character of falling. This approach applied to atmospheric pressure relieves us from the notion of gravity forcing the atmosphere into a pressure gradient, i.e., compressing air. It does not. The air particles do it voluntarily within a contained adiabatic column of gas. There will thus be a pressure and density gradient such that energy per volume is maintained constant. So there you go. So those were the two I had picked to read. Does anyone else want to read one? Do you have any thoughts or questions about those?
I got one or two. Did nobody else bring one to read?
I do have one.
Oh, well, you're welcome to read if you'd like.
Cool. Which one did you pick?
I've got what do most people misunderstand about
About which?
about Einstein's theory of relativity?
Cool.
Nice.
I do have a question about one of the ones you were reading, Toby. If that's okay.
Yeah, of course. Let's do that.
I mean, if anybody can explain this to me, he made note that the compression of the atmosphere in relation to the volume. Can someone expand on that a little bit or make sense of that for me?
In what context?
Well, I guess he was trying to equate it to like, is the gas falling or is it just at rest? And then I guess the difference is in pressure, because if it were being compressed, it wouldn't change the volume of the gas. I don't know. I'm thinking maybe I missed something. I was hoping somebody could elaborate on it if they understood it.
It's more like one is dependent on the other instead. I think you have the relationship cause and
Okay.
effect wise inverted, maybe. That as well. Remember what I pointed out mid reading for that page, that there is a dissimilarity between phase of matter here, that the solids and the liquids don't act the same as a gas, or I should say conversely, the gas does not act like the
Yeah.
rest of those two because of its energy state. That's why it's a gas. And because it's a gas and has a heightened energy state, it ignores gravity and expands to fill the container that it's in. Explosively so. We always talk about it on those terms, right? So you have to continue that constant in your analysis when you talk about pressure and the number of them.
And on that note, when you said that gas ignores gravity, so like if I watched, how do I say this? Like if okay, this is kind of crass. If somebody farts in a pool, right? You get this plume effect. Now, is that simply because of its buoyant nature or because of the unequal force from its origin? Or because like if you're saying goes in all directions, I would just imagine like this like perfect circle like pluming out of the butt. But clearly it makes like a mushroom head shape and goes upwards and kind of disperses and stuff, you know. So there's this like other relationship happening.
Well, you're seeing its natural tendency to go up because it's far less
Yeah.
dense. That's just buoyancy at work there on the first principle. But you're right, it does plume outward. It expands, it attempts to expand in all directions, but of course, the density of the medium around it is restricting that to
Right.
such a high
It's
degree
the more
because the
dominant.
contrast in densities is so high. The contrast amongst the gases we're looking at in the atmosphere, there's no other thing to contrast it with. It's already just the gas. You know what I mean? The liquids and the solids are already well underneath it. So it's a slightly different analysis on that term.
Yeah. Well, let's move away from the fart. Maybe like a train with its smokestack, or like let's see, maybe like a volcano going off or something. Like I see these
Those two
pictures.
involve a fair bit of convection, though, too, right? That's a matter
Right.
of
Yeah.
one gas
Kind of
inside another
not a
gas
good
with a different
control.
energy state.
Anyways, you answered my question. I do appreciate that. Don't want to take up all the
Good
reading
thing.
time.
All good. I mean, we're all just. It's not like we're got a line out the door or anything like that. So all good. Did you want to read Flatless? You don't have to. Like, don't feel pressured to if you didn't want to, but you want to.
That'd be great.
No,
Yeah,
I'm
go for
down.
it.
This one's not too long.
Cool. Do you want to drop? Can you drop the link in the chat by any chance?
I have a link to the question,
Or you can just
but
tell
I
me the
don't.
name.
Okay, the name is "What Do Most People Misunderstand About Einstein's Theory of Relativity?" There's not really any diagrams or pictures on this one.
Oh, cool. Okay, yeah, you can go and start reading whenever. I'll pull it up here.
All right. What do most people misunderstand about Einstein's theory of relativity? First misunderstanding, that it is a theory. Relativity is not a theory at all. It is an exercise, an attempt to create something as powerful and as successful as thermodynamics, but for gravity, as Einstein himself tells us. Quote, by and by, I despaired the possibility of discovering the true laws by means of constructive efforts based on known facts. The longer and more disparagingly I tried, the more I came to the conviction that only the discovery of a universal formal principle could lead us to the assured results. The example I saw before me was thermodynamics. End quote. That's from Einstein Autobiographical Notes. The problem was that Einstein lived in the wrong century, a century that has denied the existence of an autonomous reality. Heisenberg famously declared objective reality as evaporated, whereas thermodynamics is based on the acceptance of an autonomous reality. Einstein was deeply impressed by the bold postulates of thermodynamics and their explanatory and predictive power. But of course, these postulates, the zero, first, second, and third law of thermodynamics, are postulates about nature, not about the observer of nature. In a desperate attempt to emulate thermodynamics, Einstein starts out with similarly bold postulates. In his 1905 paper, he simply elevates assumptions to principles and builds a mathematical construction upon these otherwise unverified and thus artificial principles. Quote, in the following, we make these assumptions, which we shall subsequently call the principle of relativity, and introduce the further assumption, an assumption which is quite at the first sight quite irreconcilable with the former one, that light is propagated in vacant space with a velocity c, which is independent of the nature of motion of the emitting body. End quote. The equally bold premise made in these first few lines of the paper foreshadows the inevitable collapse of the card house. These two assumptions are quite sufficient to give us a simple, consistent theory of electrodynamics of moving bodies on the basis of the Maxwellian theory for bodies at rest. There is no such thing as an electrodynamic of moving bodies in physical reality, because moving bodies are a projection through space, whereas electrodynamics is a process in time. Consequently and predictably, this attempt ended in failure, as a theory based on such assumptions tells us nothing about our universe and has no explanatory or predictive power whatsoever. Einstein had to find this out the hard way while working on a generalization of relativity. Like string theory later, which offers 10 to the 500 decimal point possible universes, none of which resembles ours. SR works everywhere except in the universe we observe. It only holds in an infinitesimally small universe observed over an infinitely short period of time. And on top of that, in absence of gravity, a place as far removed from observed reality as it can possibly be. Quote, within an infinitely small space-time region, one can always find a reference frame. An infinitely small elevator cabin observed over an infinitely brief period of time in which the laws of physics are the same as in special relativity. From this follows that the entire conceptual system of the theory of SR can claim rigorous validity only for those space-time domains where gravitational fields are absent. That's 1920. Okay, and that leads us to the second fundamental misunderstanding, that GR is generalization of SR. It is not. On the contrary, it is about a 180-degree about face, because the assumptions elevated to principles at the core of SR have just crumbled under their own inadequacy. When Einstein tried to extend SR to incorporate gravity, he realized that in order to combine the massless phenomena light with gravity, he had to treat gravity as a medium with a property similar to the refractive index of other media. Because gravity is a law of position, the function of refractive index would be played by position. And as is the case with the refractive indices of other media, this would mean the end of a constant velocity of light, even in a vacuum. Okay, we got some quotes. From the just proved assertion that the speed of light in a gravity field is a function of position, it is easily deduced from Huygens' principle that light rays propagating at right angles to the gravity field must experience curvature. The speed of light is not constant but depends on position. Therefore, one is forced to generalize the theory of space and time known as relativity. This has far-reaching consequences, as now the concepts of space and time are reified entities. The principle of gravity has become a medium, and the last unreified concept, the vacuum, i.e. space without physical properties, would also no longer be tenable. Einstein slowly worked his way back from the premature promise made in his 1905 paper, The Introduction of a Light Aether, it's a German word, will be proved to be superfluous. First the excuse. In 1905, I was of the opinion that I was no longer allowed to speak about the ether in physics. This opinion, however, was too radical, as we will see later when we discuss the general theory of relativity. Then the new promise. One can thus say that the ether is resurrected in the general theory of relativity. Since the new theory, metric facts can no longer be separated from true physical facts. The concepts of space and ether have merged together. And finally, convinced that, according to the general theory of relativity, space without ether is unthinkable. For in such space, there would not only be no propagation of light, but also no possibility of existence for standards of space and time measuring rods and clocks, nor therefore any space-time intervals in the physical sense. At a lecture in Tokyo, 1923, Einstein does not hold back in selling GR as an ether theory. Quote, light propagates through the sea of ether in which the earth is moving. In other words, the ether is moving with respect to the earth. Combine that with, as a simple geometric consideration shows, the curvature of light rays occurs only in spaces where the speed of light is variable. End quote. And you will begin to understand how much you misunderstood about Einstein and his relativity circus. Okay, that's the end.
Wow. That's another good one. I'm muted. Okay, good. I'm not. Yo, thanks for reading, Flatless.
Yeah, no problem, man.
Just kind of scrolling back through it. Like throws out the ether, then admits he needs the ether. Just classic Einstein.
Yeah, that guy cracks me up.
Yeah. Cool. Well, did anyone else want to read anything? Did anyone else want to bring anything up? Have any questions before we wrap things up here? Or yeah, anything?
I got a couple.
Go for it.
Oh, I think we might want to play with Cavendish. He wrote some really humorous stuff. It's in the Brenner Comp package.
Oh yeah.
It's just called the Cavendish experiment.
Yeah. Let me pull it up.
Before you get started, I just want to say I will read if we're still going in like 30 minutes. I just got off work and I'm driving, but if we're still going on in about a half hour, I'll totally read one or
Cool.
two.
We'll wait up for you.
So it's just called the Cavendish experiment.
Yep, it's the one that begins, is it a valid experiment of gravity? When you go up to the market and buy an apple. That's a 5-pager. Yeah, the title in the ODT document is just Cavendish experiment. I took the yield.
Uh,
It's in the big zip file.
Here, I think I found it. When you go to the market to buy an apple, does he say that?
Yep, that's
Oh,
the one.
cool. I found it then. Am I already sharing my screen?
All right, good stuff.
Cool.
Let's rock. So when you do go to the market to buy an apple, and the vendor puts it on a scale which never comes to rest, but still he claims he's measured the weight of the apple to 50 millionths part while watching the scale in full swing, you'll just turn around, leaving him standing as the fraud as he is. When Cavendish does exactly that, the world accepts it with applause, awestruck by his performance. The Cavendish experiment is not a measurement of weight. It is not a torsion balance because the scale never balances, that is, never reaches equilibrium. So when we look at that little diagram right there, the torsion wire is the thing that tells us what the forces we are actually measuring here in terms of theta coming away from the center of rotation. And it is the attraction F caused by the reduction of R or the increase in masses M and M that would cause the thing to turn. If everybody can see that. This is actually a symmetrical balance, geometrically speaking, of two pairs of attracting bodies, both contributing to the torsion we see on the wire produced by the angle theta. Hope that's fairly clear. So, quote, actually the rod was never at rest. Cavendish had to measure the deflection angle of the rod while it was oscillating. So what Cavendish got was a torsion pendulum, not a balance. The amplitude of the swing was 4 millimeters, but he had, of course, no idea where exactly the two forces really balanced out, simply because they never did. This is in stark contrast to how Coulomb operated his torsion balance in 1777. Another quote, if an unknown force is applied at right angles to the ends of the bar will rotate, twisting the fiber until it reaches an equilibrium, where the twisting force or torque of the fiber balances the applied force, as in the attractive pairs of forces we're looking in that diagram. Then the magnitude of the force is proportional to the angle of the bar, and that's theta, the theta change. This is measuring the amount of force that we're looking at. And then we go to the next diagram, where the torsion fiber in a cylindrical jar with the same kind of thing going on, only they show only one, quote, negatively charged pith ball. There will be a second one on the other side, of course. And we're reading the scale there instead of trying to read something that happens to the fiber itself. And the scale, of course, is where we're getting theta from. So as the Cavendish experiment represents a dynamic situation where masses never come to rest, the law of inertia totally destroys any validity of the outcome. Law number one, and this of course will be, fairly Newton-esque, every body persists in its state of being at rest or of moving uniformly straight forward, except insofar as it is compelled to change its state by force impressed. Once the two small balls are in motion, they will strive to continue to do so. That means they will overshoot the point of balance until the twist of the wire brings the bar to a stop and re-accelerates it in the other direction, where again they will overshoot and the whole dance repeats. If it never reaches an equilibrium, you have no idea what you're measuring. I hope that's clear to everybody that what we're talking about are the two forces, the torsion in the wire and the attraction of these charged pith balls, or in Cavendish's experiment, the attraction of the masses. That there's a balance between those two, and you're actually creating a pendulum, a rotational pendulum between those two forces. F equals k theta over L, which is supposed to be the same as GMM over R squared. Here, if you don't have a stable reading for theta, you have nothing. The overshooting is directly reflected in the result. The calculated density of Earth with 5 grams per cubic centimeter is some 80% higher than the actually measured density of 3 grams per cubic centimeter, which then has to be compensated for with a fictitious, I think the word fictional is a better use, and fictitious is what he wrote here. And I think in terms of the language, fictional is it. Fictional dark sense a dark dense mass in the center of the Earth. So to repeat that, which then has to be compensated for with a fictional dark dense mass in the center of the Earth. Here's the quote. The result of 5.4 grams per cubic centimeter, oh yeah, is 80% higher than the density of Earth's outer crust, suggesting the existence of a dense iron core. But a solid iron core embedded in the liquid mantle of a rotating sphere is a complete dynamic impossibility. Nothing would hold it there, as in there at the center, as gravity at the center of the body is zero. And when we look at this curve, I'm not so sure that it's a straight line from 0 to r. That I mean, I didn't do the spreadsheet, the calculations on this one, the interaction between n and m here. I mean, he shows parabolic to the right of the surface, above the surface, and that's correct. That's according to r squared. But I think r squared is kind of applying to the left side of that surface dotted line as well. I think that might be a slightly parabolic curve as well, and not in a symmetrical way because we're coming away from zero. But anyways, those are my abstract thoughts about the graph.
What an even function,
On the
right?
contrary, yeah, it'll just be a different slope or quadratic, I guess, entirely. Somewhat different, let's just say that. On the contrary, because a rotating vessel containing viscous materials is per definition a centrifuge, all heavier mass particles will want to wander towards the periphery and not towards the center, driven outward by the inertial force per unit mass. And that's F over m equals omega to the exponent of 2r, as in squared also to the exponent of the radius, and that's going to be big R in the diagram above. And what I would point out there, that this equation is pointing at inertial force per unit mass, when really we want to look at the force relative to what we're talking about with our R. We would fill in the blanks for the M and the R, and then we would multiply both sides by M, so that you would read that F equals omega to the exponent 2r times m. It's kind of like FMA. And that's how he's quantifying it using a formula. Again, Cavendish claims to measure with his swinging setup 0.000000174 newtons, which leads to the postulate of an even less number, as an even smaller in magnitude number, ironically called big G, which is 0.000000661 and some other numbers. And I would stop right here and agree with him that he says it's so far beyond reasonable, it's mind-numbing. And personally, I find that to be true on two different points, but we'll just cover one, and that is the level of precision. Let's remember what year we're in, gang. This is the 19th century. Even like before Cavendish, you know, and even before that. I call Cavendish early 20th, 100 years ago. You know, that's all fine and dandy. Think of the technology people were embracing at or just after the First World War. Like, think about aircraft. And, you know, that's the technological level that they were at. But somehow these people are asserting measurements of constants in excess of the 12th decimal place in terms of precision. Yeah, okay. When this fantasy number actually met the really big guys, i.e. galaxies, in the 1930s, it became obvious what a scam that measurement really was. But hey, we never admit anything. We just move forward with postulating new dark stuff, which again cannot be verified, as well as very conveniently not falsified. How do you falsify something that cannot be directly accessed or measured in this case? And that is something we should be using far more frequently in debate with globies. While we are in the swinging business, let's have a look at another showpiece, the Foucault pendulum. As Cavendish and Foucault are two of the most popular arguments supporting accepted notions about the condition and motion of our Earth. Right off the bat, all modern exhibition pieces are driven in order to make sure the audience always gets the right impression. When you look into accounts of historic non-driven pendulums, you will find their behavior is all over the place. I love that expression, and I even used it when talking about Bob Nodell's data being all over the place. I really like Brenner, you know what I mean? Anyways, the behavior's all over the place, rotating wrong direction, wrong period, erratic altogether. In short, very unpredictable. And that is only to be expected because a long wire moving through air will inescapably be set in micro vibrations which will influence the swing. Sometimes it was just a matter of switching the same wire end for end, and the direction of the precession would switch too. Apart from that, what such a pendulum would really show is the asymmetry between radial gravitational acceleration, g m over r squared, and axial rotational acceleration, which is 8 omega squared r cosine alpha. Alpha being the latitude, and that's what he's talking about below in this diagram. The asymmetry is not observed, wherefore the whole exercise is certainly not showing what it is said to show, but clearly shows what nobody wants it to show: absence of sphericity as well as absence of rotation. And while we're talking rotation, we know experimentally how freely rotating objects behave. They will always adjust their rotational axis to the minimum energy state. That is, the will to always rotate with maximum momentum. In case of a freely spinning Earth with viscous interior allowing for the dissipation of energy, the rotational axis will be such that the land masses are spread out over the rotational equator. Is this the case? Does the rotational axis of Earth go through the Pacific? Clearly not. And thus, the Earth cannot be a freely spinning ball. This guy
Yo,
is gold.
thanks for reading, Stone. That was fantastic.
My pleasure. My
Especially
absolute
loved
pleasure.
you were like really, really ready to break down the experiment with all the variables. That was perfect. I really appreciated that.
We aim to please. So, who's got questions about this paper? Is the issue here? I want to hear from you guys what you thought of what I just read.
Man, I just got here off to check it out. What was this one regarding?
Good thing, Alan. This is
Cavendish?
about Cavendish. Yeah.
Oh, perfect, dude. This is like my next stop of operations. Nice.
So we bought the apple and we spun the wire and we attracted it with electrostatic instead of just mass in the second diagram, right? And then we started to talk about all the ridiculousness of the measurements they claim to be taking by the end.
Nice.
More specifically to the point, the bloody number of decimal points in their exponent, that's 6.67 times 10 to the negative 11, just for starters.
Yeah, that's how you know you're in good shape, dude, when you get down to the neg 11s.
I love Brenner calling out that it's ironically called Big G. It's only 11
dude, it's a
decimal
baby
places.
G.
And then he goes to the big G, the galaxies, and talks about the necessity for the dark matter and stuff to satisfy the equation, the reification process, academically speaking.
Man, that's so wild, dude. It wasn't enough at all. They applied those kinematics from Kepler and they were like, "Oh, look, we can explain everything." And then they just kept finding more stuff.
Man.
And that's unfortunate, you know. Sometimes you just rickroll yourself.
And that's funny as hell.
So yeah,
Big
we've already
G,
read,
negative 11.
we've already read a few. Yeah, does anyone else have questions about this one? For Stone, or thoughts or anything? I also
liked the Cavendish. Oh, sorry. Go ahead.
I was just gonna say I also loved your breakdown of Newton's shell theorem, because that's something that I'm still trying to kind of get a handle on.
I'm not quite there. Which part?
The part where he was showing the magnitude of the gravitational force being the greatest at the surface of the sphere versus the center.
Oh, yes, indeed. Yeah, I don't know. I kind of want to attack that curve a little bit to see if the left side is a straight line like that. The straight
Yeah,
slope.
are you hinting at a
kinda
possible
weird,
Stone
eh?
vid about the concept? I would like to
God,
see
I'm
that.
still working on the atmosphere one, and everything we talked about with the ideal gas law tonight is quite aligned with that. Even though it's still almost in pre-production, it's way back.
Nice. That sounds very promising. Cool. Well, then, yeah. Did anyone want to read one? Alan, did you bring one to read?
So I do have a Brenner comp that we can read. Give me 1 sec. Let me put my
But his
glasses
cat ate it.
on. Oh, that's yeah. My cat ate it. So we'll actually
showed up
catch you guys in the
showed
next
up
comp.
late, and his cat ate his Brenner comp.
Yep. No. How long you guys been live? Do you want to do another one?
Absolutely.
you.
Oh,
I got
20
you. I
minutes.
got you
Yeah,
on the
lots of
quantum.
time. We're waiting
Okay,
for
cool,
Brandon
cool.
to come back too.
Awesome. Yeah, I apologize for being late.
You're good, man.
I had a
Harassing
thing
you.
to.
Life gets in the way.
Brenner comp. Here we go. All right, let's do the old sharing of the screens. Oops, that's too many bits for Stone. 1 second.
She's breaking up
Like-
cotton. She
It looks
gonna
like-
take it.
It looks like
It's like-
240p.
Dude, I put it at 440p or whatever for Stone the other night.
No. Toby was delightful at 720/15, but we'll do 30. That's cool. Like we're
Oh, no,
watching
no.
some really rip-rod action in 30 frames.
Yeah,
But, go ahead.
You don't want to
Yeah,
miss
no.
the scroll down.
Dude, yeah, it's back on. You don't want to miss that smooth scroll text. So let's see. You guys just did Cavendish, and I was going to do a quantum one here. Let's see. How real is quantum physics, or has Einstein's theory of relativity been proven?
Ooh, is that the one we did? No, it's not the one we did.
Ooh.
No,
You know what?
we
I
touched
kinda
on
wanna do-
Einstein.
Oh, did you guys? Okay, we'll do. How long?
No, that sounded provocative, man.
Which one?
That one right there.
How real is quantum?
I think so. We don't talk about quantum physics much here.
Oh, dude, it's a subject we're just dabbling into, bro.
Schrödinger, that pinhead. Let's go.
So it turns out Schrödinger made this analogy to make fun of the ridiculousness of it all. He was
And then
clowning
they
his boy Max
embraced it.
Born. And dude, I know, right? Isn't that so funny how they turn it into like this like profound
It's not a
philosophical
debunk.
statement?
It's not
They're
a
like,
debunk. It's ours now.
Yeah, they're like because okay, what happened was Schrödinger has this epic wave equation, right, that solves everything for them, and then Max Born goes, "Hey, if we square that, we could say that the solution to that is the probability of where the where these charged particles exist, right, namely the electron and photon and all that kind of stuff, right?" And he says, "Well, there's no way we could ever prove this, and if you want to believe in it, you just kind of have to accept it. And here's the math for it. It's all very cool." And Schrödinger was like, "Hey, that's hella retarded. If you take a cat, put it in a box, blah, 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 it does the Schrödinger's cat thing. And then now that's turned into like this, the profundity of quantum mechanics, right?
So
Is
cool.
that you
deep.
could solve an equation and bring a cat back to life or something." So it's,
He just didn't realize how deep he actually is.
yeah, he
solve an
was,
equation and bring a cat back to life.
dude, it's something like that. If you don't solve it, the cat dies. I think that's how it works. So that's why I haven't really dabbled in quantum too much, because I'm not trying to like mass kill cats.
Yeah,
you know?
SPCA will get on your ass.
Yeah, all right, so let's get Brenner comp, lads. All right, so How Real is Quantum Physics by Michael Brenner. Quantum physics is as real as any Stone, help me out. Catechism?
That's a catechism.
Catechism. Okay, a catechism is a willful distortion and misinterpretation of an underlying textual reality, which makes it pseudo scripture, and quantum mechanics is pseudoscience. That is the willful distortion of an underlying physical reality. Shout out to Brenner, dude. We're like, how many commas was that? We're one sentence in, and he's already
And he's
encapsulated.
throwing down.
Dude, he's throwing down the gauntlet, dude. All right. So, contrary to catechisms, the pseudoscience quantum physics denies the existence of autonomous underlying reality. In the Copenhagen interpretation of quantum mechanics, the objective reality has evaporated. Quote from old Schmeisenschmerg. So, as we were talking about earlier, they can't prove any of this, and their philosophy is if you want to believe in it, you just have to be down with never being able to find the actual physical particle. That's from Heisenberg and Born, so
At least he's not afraid to say it, I like him for that.
Says it with his chest, bro. Respect. So, I have already written exclusively about catechisms of relativity and quantum mechanics, but this time I want to concentrate on the aspect of willful distortion of the underlying physical as well as historical reality, focusing on Erwin Schrödinger, who falsely is associated with the quantum mechanics of Max Born. Yep. All right, 1 second. I'm gonna hit this water real quick. All right, Toby, what do you think is gonna happen to this cat when we open this box, brother? Did you do your homework last night or what? Is this cat dead?
He's going to have kittens.
Oh,
I spent all
Dude.
night doing my homework, and all I could figure out is that we're not going to know if it's dead or alive until we open the box.
All right, I think you're correct. Let's begin with the most brazen distortion of the case, the famous cat of Schrödinger. And then here we have a cat that's alive, a cat that is sleeping and or dead. We have a broken poison vial here, and that's it. So the Wikipedia article makes it sound as if Schrödinger came up with this thought.
Actually, one sec, Alan. Alan, for
Yeah.
everybody to fully understand that image, the last thing you touched on was not quite there. That black box there is something that is decaying at a given rate. And we don't know if the next decaying energy particle has shot out of it and hit the receiver yet. We're trying to figure out the decay rate of something and how long do we wait even before we check to see if the cat's alive or dead. That's the mechanism going on here.
Ah, see, I didn't even know that. Thank you, Stone. Adding that cat poisoning contextualism to it. Thank you. So this Wikipedia makes it sound as if Schrödinger came up with this thought experiment to teach quantum mechanics when in fact he used it to show how ridiculous and ludicrous it is. In German, yeah, okay. The whole premise of quantum mechanics, or yeah, how ridiculous the premise actually is, right? This whole situation for how long do we wait before we find out if the cats are alive or dead based on the hypothetical particle, when it'll be interacting with that switch there to kill the cat. In this translation of the cat paradox paper, and then we have the citation here. So this is Schrödinger, not sure on the year, but the present situation in quantum mechanics, the translation of Schrödinger's cat paradox paper. Here, or when Schrödinger makes it clear here what he means, one can even set up a quite ridiculous case, a cat penned in a steel chamber along with the following diabolical device, which must be secured against direct interference by the cat. Dude, I like how anyway. And he's just like taking it to the full extreme. Like the cat can't mess with it. Anyway, let's see. So to be secured against it can't be feared. In a Geiger counter, there's a tiny bit of radioactive substance, so small perhaps that of course perhaps 1 hour the atom decays, but also with equal probability perhaps none. And if that happens, the counter tube discharge and through a relay releases a hammer which shatters the flask of hydrocyanic
acid.
Hydrocyanic acid.
Yeah,
And then,
the good stuff.
Yeah, stuff we were all doing in middle school or whatever. If one has left the entire system to itself for an hour, one would say the cat still lives. If meanwhile no atom has if no atom has decayed, if the first atom decayed, then it would be poisoned. And the psi function here, so this is his wave equation or part of it. The entire system would represents the system or whatever. Let's see, would express this by having in a living in the dead cat, blah blah blah, right? It would be smear out the equal parts. Cool. So he's, to be clear, he's not using this in a positive light, right? For quantum mechanics. So, and this comes out to Schrödinger in vain tried to convince the scientific community that the whole of quantum thing is not only irrational, but the invention of new physics for small scales is unnecessary. It is totally irrational to believe that nature makes a scale distinct in the way that she behaves, a scale distinction that is somehow geared towards what humans consider big or small. It is equally irrational to believe that randomness is randomness, the abandonment of causality. Believe that randomness, the abandonment of causality, can be the physical basis of a strong, resilient nature, and that becomes even more out of out of science with new catechisms of belief. In the words of Immanuel Kant, causality is the basis of all scientific work. Causality is the condition that renders science possible. And in the words of W. Heisenberg, the law of causality is no longer applied in quantum theory. Nice. So, quantum theory is not science. It is a belief in an interpretation. Facts. They even tell you it right in Max Born's 1926 paper. Schrödinger tells us or shows us that this belief is unfounded and that classical physics is very well capable of describing what we call the small world of atoms. In 1928,
Doesn't that sound like a Disney ride?
the world of small atoms.
I'm going down to Epcot Center. I'll drop a B ticket on that. Let's go.
Yo, and real quick, I just want to shout out to Schrödinger. Like, I know the dude had a dark side that I don't want to talk about, but like, just like, he's like looking at the insanity of the world, of like the physics world around him. He's like, guys, like, yeah, like you got this cat. You're saying this cat's like dead or alive, and it's not even even dead or alive till you open the body. He like puts it all out there, like lays it all out so succinctly. Like, this is how stupid your guys' theory is, and then he just watches the world around him and go, yeah, and pick it up and run with it, and just like, yeah, Schrodinger's cat. This is quantum mechanics. So like the whole world just like warps around it. Like, how surreal must that have been?
Turn to alcoholism.
Yeah, I can kind of sympathize with that. Anyways.
In 1928, Schrödinger holds 4 lectures in Berlin, where the title alone would be enough to clarify things is about wave mechanics and not quantum particle mechanics. Oh, no way. 4 lectures on wave mechanics. Huh. What do you guys think he's talking about there? Tiny particles, right?
Cats in boxes that may or may not be there.
The probability of how the more you know, precisely you know the momentum of a particle, you can't know its physical location. Do you think he was like tied up in that or no? Just judging by the title. All right. Schrödinger does point out, though, that ordinary mechanics is an approximation that does no longer hold for very small systems. But what does he mean by that? With ordinary mechanics, he means geometrical optics, in which he treats rays like mechanical paths of mass points. 1 second, water. All right, where are we at here? Wave cats, first lecture.
We're in with Hamilton, yeah.
Yes. Hamilton's wave picture worked out in the way discussed above contains something that corresponds to ordinary mechanics. What does this V's? What does this mean, Stone?
Essentially vis-a-vis, as in how we see.
Gotcha. Okay, so vis-a-vis, the rays correspond to mechanical paths and the signals move like mass points. But the description of the wave motion in terms of rays is merely an approximation called geometrical optics in the case of light rays. It only holds if the structure of the wave phenomenon would happen to be dealing with is coarse compared to the wavelength and as long as we're only interested in its coarse structure. Schrödinger suggests is replacing ray mechanics with wave mechanics. So this is, okay, we'll start. Hence, in replacing ordinary mechanics by wave mechanics, we may hope on one hand to retain ordinary mechanics as an approximation which is valid for the coarse macro mechanical phenomenon, and on the other hand, get to an explanation of the most minute micro mechanical phenomenon, motion of electrons in the atom, about which ordinary mechanics is quite, and then it cuts off. Okay, so not particles, just the opposite of what quantum mechanics teaches. So we're reading here through some of the 4 lectures. We're reading some excerpts here. So wave mechanics again, ordinary wave mechanics, geometrical optics, undulatory optics are equals undulatory optics. Cool. So quantum theory treats the electron as a particle moving along a path, and Schrödinger treats the electron as a vibrational wave of a field of negative charge. And Stone, how would you interpret that, right? Because obviously these people didn't think there was a negative charge. Like they're just talking about a lower energy state than anything else, right? That's how I interpret
Well,
it when they
I
talk about
think
that.
this is a conflict between North America and everybody over on zero longitude, essentially, that they embrace the left-hand rule as well. So I have a nomenclature-based problem with a lot of what they wrote back then concerning negative charge. Ionization is always the negative sign we're applying to something. And I think that's part of the mass overlying set of illusions that they want to leave us with that don't represent reality at all, so that we will never progress as a species. Further, this paper about wave mechanics, as far as I've heard in the past and even the recent past, is that this is the source of the initial act of plagiarism known as quantum mechanics. That these people not only took his cat theorem and amplified it, saying, yes, that's actually what it is, because we're too stupid to come up with a better analogy. That must be what it is. And here he's saying, no, this is actually about wave mechanics, not particle mechanics, because they don't have any mass to begin with. They're the first people to use terms like massless particle. It's ludicrous. But here, he's into the empirical. He's into wave mechanics, optics, things you do with light in the lab. He's the guy coming up with the real meat, I think, that was plagiarized by these guys in the societies to produce what we now interpret as quantum mechanics. That's kind of what I'm thinking there.
Yeah, it seems like they just leached a lot off of him, and he couldn't really see. Do you know about
they turned it into something stupid and educated everybody with it?
Yeah. Do you know about the EPR paper, the Einstein, Penrose, and whatever the other guy was, Paul Rosen or something like that? You know about that
what's
paper?
What's the title? I don't think so.
Well, basically, they body bag quantum mechanics with wave particle duality because of the way the equations work. If you can analyze one particle in the system, and then at the end of it, you can still determine like the other system without measuring it. So it totally defeats the whole wave collapsing situation thing. And there's no explanation for it.
I'm hoping you're also telling me that they debunked duality as well.
No. So he did it to keep duality. So it only debunks the Heisenberg uncertainty principle part of quantum mechanics. But anyway, it completely destroyed it because that's like fundamental, right? As we just read, this is all philosophical gobbledygook. But then
exactly.
What Einstein and Penrose and the boys showed is mathematically you can defeat Heisenberg's uncertainty principle and still analyze the second particle without collapsing it, et cetera, et cetera. So these guys, anyway, it fully collapsed. Dirac and what's this guy's name? Heisenberg. They couldn't refute it. And they just, what saved them was the Compton effect, basically.
Yeah, Dirac's hardcore too. But I think what you're actually saying, the overarching point is that they can use mathematics to prove anything. And that's exactly what they've done here.
Yep. Yeah, because it says it in plain English in Max Born's paper 1926, where he's just like, it can't be proven, but it's a cool thing and I like it. I'm into it. You guys want to join me? It's like, no.
Even today, I am still consistently assaulted with, hey man, the math works out. What's your refutation? It's like, the problem is that's all that works out.
Yeah, exactly, dude. Exactly. Yeah. So we'll keep going here. So that was, we were figuring out what they mean by negative charge and all that.
Yeah, we're just getting to the hypothesis there.
Yep, absolutely. All right. So, and by waving this electron medium, he is able to explain what we observe experimentally about atoms, and it's consistent with ordinary electrodynamics. That is the classical electrodynamics of Maxwell. Those are my favorite electrodynamics. What about you guys?
They seem to work, which is cool. They don't have fantasy particles, which is cool.
You can't touch Clint Maxwell.
Nice. See, I'd like to have Stone take a look at that displacement current, though, and see if we can fix that. But other than that, looks great. So let's see here. We have, just read the whole thing. The hypothesis, so we're reading now from the lecture still. So the hypothesis, which we have to admit, is very simple, namely that the square of the absolute value of psi is proportional to the electron density, which causes emission of the light according to the laws of ordinary electrodynamics. Since the square is the absolute value of psi, is formed by multiplying psi by the conjugate complex quantity, which is called psi line over it.
The average psi, that's what I use that term to line for, is to express average.
Oh, right,
But I guess
right, yeah.
conjugate psi was what they would call that then. Conjugate psi?
Yeah, so the old conjugate psi. A glance at the expression, equation 15, shows that the term composes of psi and the psi conjugate expression with the complex quantity contained the time in the form of the cosine factors of the desired frequencies v sub k minus v sub k prime. More precisely, let us point out that the charge density p, or no, that's not p. What is that? Rho. Rho equals minus e times psi times the conjugate complexity thing minus e. Yeah, get more into that. So what's going on there, Stone? You know anything about that?
Nope, not a thing. Some of the constants, and then he's adding c a couple times. Well, that just seems like a coordinate comparison, really, because he's got it and prime, it and prime, it and prime all the way through it, and he's got energy off the beginning negatived, and then he's got energy in the middle squared to the same exponent. What is that? 2, I can't quite see it, 2 pi I under there, that teeny little thing there, yeah.
So is he essentially describing the conjugate relationship?
Between?
Essentially of the EM wave. Like the conjugate relationship between essentially the electric and electric and magnetic constant, isn't it? Or how does that conjugate wave, like, I don't know what the two different conjugate parts are called, but the two conjugate parts of an EM wave.
Yeah, I'm not seeing what the comparison is here, frankly. Yeah, I don't know, man. But he's getting all spherical about it using a cosine function, and that's all fine. Great. Again, we talk about static charge and point source and all those cool things about how it doesn't resemble what's going on with gravity on Earth. And it's, again, we're relating back to static theory, the charged particle quote. And I think that's where he's invoking R and pi, or cosine rather, and pi. It's all about a rotational aspect that doesn't even exist.
Oh, yeah, the old rotation that doesn't... Oh, shout out to my boys Stark and Zeman. I see these lads in here. All right, so we'll continue on. The correctness of our psi conjugate expression hypothesis has been checked by calculating the a sub k prime. Dude, what the heck is this? If somebody's, dude, anyway, so by calculating this right here, in those cases where the psi sub k, yeah, dude, apostrophe s are
yeah, psi sub k's.
Yeah, psi sub k apostrophe s. Or do you just say it with like that?
So I think
psi sub k's.
Right, he's literally saying like plurals. Yeah.
Oh, gotcha. Okay, I thought he was throwing in a new math.
No, actually, possessive. Apostrophe
S.
It is the thing that belongs to psi sub k.
Has been checked by calculating the. But what about the one before that? By calculating the a k k prime s's.
In those cases,
I think he's doing plurals.
Yeah, same. Okay, these sufficiently are well defined. Namely, in the case of the Zeeman and Stark effects. Shout out to the boys. The so-called rules of selection and polarization and the intensity distribution in these patterns are well described by this in the following obvious way, and the description is complete and in complete agreement with experiment. So just think about what Schrödinger did here. He just made the quantum theory obsolete, because his wave equation describes the atomic experiments, and he does this using classical physics. No way. Yo, shout out to Michael Brenner for pointing that out and making it super easy.
Right back to wave mechanics. Exactly.
Right back to where we've always been and never left. How many vibrations are happening in a second, guys? That's where I feel most comfortable. All right. So let's see here.
There you go.
So we got a half Wikipedia page quote from
Oh.
Brenner.
Gotcha. Still going.
Yeah, it
Nice.
keeps going. So let's see here. So we have here you are referred to a page about Schrödinger's equation, where you are inevitably gilded back to quantum physics, which Schrödinger showed us was unnecessary and obsolete. Oh, he's showing us how when you go to Wikipedia to say, you know, what's going on here? Is this a wave particle? Is the ether real? What's going on? What Wikipedia is going to tell you about Schrödinger and the old wave equation. So we'll just read from Wikipedia too. So the Schrödinger equation is a linear partial differential equation that governs the wave function of a quantum mechanical system. It is a key result in quantum mechanics, and its discovery was a significant landmark in the development of the subject. The equation is named after Schrödinger, who postulated the equation in 1925, published it in 1926. Dude, it didn't even take a year for Max Born to come along and go, hey, if we square this, we can have a whole new thing. Forming the basis of that postulate, he won the Nobel Prize in 1930 thrice. So when and how did quantum physics become separated physics to begin with? Where did the split happen? It was Niels Bohr who introduced the Bohr atomic model based on a rather medieval conceptualization of Rutherford in this paper. The constitution of atoms and molecules. Oh, we'll have to cop that. Let's see. Oh, we'll read here. So this is from your boy Bohr. Introduction. In order to explain the results of the experiment of the scattering rays alpha by Professor Matt Rutherford has been given the theory of the structure of atomic atoms. According to this theory, the atoms consist of positively charged nucleus surrounded by a system of electrons kept together by attractive forces from the nucleus. The total negative charge of the electrons is equal to the positive charge of the nucleus. Further, the nucleus is assumed to be at the seat of, and we'll never know the rest of that, which I'm completely fine with. So then Brenner takes over again. So he says, where he claims that classical electrodynamics is inadequate to describe the behavior of systems of atomic size is the opposite of what Schrödinger demonstrated above. He spent 10 years trying to figure out quantum weirdness. Oh yeah, dude, they describe nature as like being weird and quantum weirdness, and like just quantum's just so weird, bro. Like if you don't understand these equations, it's just weird.
And then they started using words like spin.
Yeah, and up and down. Dude, that's such a punk, bro. Like, you're just going to look a grown man in the eye and talk about up spin, down spin, bottom spin, top spin. What? You're just saying the same thing with different words. Anyway, so let's see. So this is part of the quantum weirdness that we just don't understand because we're just common folk or whatever. So in the end, the math comes pretty close to matching experimental data, but at the cost of introducing a new physics, that of the particle, which are orbiting a stationary state as well as being capable of instantaneously changing their position in space.
There's that duality sucker punch again.
Yep. Then Schrödinger comes in, wipes it all off the table with classic mechanics. If we have two models, one introducing magic and one based on proven physics, it should be obvious which one should win out and which one should not. But the agenda-driven physical theology, as Leibniz would call it, Nobel laureate Irving Langmuir, I don't know. Langmuir had somewhat a more terse term with this pathological science. Now, going back to Schrödinger's wave mechanics, his wave-based math was in complete agreement with experiments. But there was a major difference here. Schrödinger explained the atom without using quantum conditions of stationary states. Oh no, we're jumping electrons. In fact, he got rid of the electron particle itself and its orbital path. No need to do a Lorentz rotation, brother. That's what's up. And went around the nucleus.
When he's talking about jumping electrons there, he's referring to the valence equation.
Yes.
Electron valence
Yeah, let me pull up a quick graphic for the old electron valence lads for those who ain't familiar.
Look, just because you didn't go and count the particles.
So we got your boy, the old
There it
periodic
is.
table of elements here. And then at the top here of each one of these columns, there's a number. This number represents the valence electrons that are available in the atomic structure of something, right? So what this would look like right there, what he was saying is we got your nucleus that's just chilling in the old stationary state, and it's surrounded by rings of electrons. I forget the rules of how many electrons go on a circuit or whatever, but the way it all works out is that the most stable particles or whatever will have one free electron at the end. So that's what they're talking about when they jump.
But
So they
take a
say
look
like,
at that diagram, guys. Now take a
Yeah.
closer look. When you're counting out from the center, the third and the fourth have the same number. They're just radially distributed.
what's the significance of that?
How's that work? How's that work? You know what I mean? There's two on the first level.
Yeah,
And
there's
Just
supposed to
then
be
is,
a-
okay?
yeah,
The math
eight.
is.
Yeah, there's supposed to be a
And
rule.
all of a sudden, oh no, that must be where the asteroid belt is after Mars.
Just quantum weirdness, Stone.
Yep.
Well, I'm catching it.
So yeah, they'll say like, oh, we did an experiment and we hit this electron here, or well, this one namely, with a photon, and it bounced it out, or it bounced it in here. Now it's at a different energy state, and now it emits light and all this kind of stuff. So like that's how they conceptualize the interactions. It's like these little billiard balls
Yeah, and
bumping into each other.
the math works out in chemistry, and it makes sense for their valence electron math and stuff. Like it all makes it works, but it's just measurements, right? It's just like charting a phenomena essentially.
Precisely. It's the separation between kinematics and dynamics. Mainstream, awesome at the former, crappy at the latter.
They're great at making things up in kinematics, dude. But then bringing it to dynamics, dude, they're like, I don't know, man, relativity, bro. We can never really know. All right. So let's see. So we got that, the old nucleus jumping, stationary states. Okay. So let me say at the outset that in this discourse I am opposing not a few special statements of quantum mechanics or quantum theory held in the 1950s. I am opposing it as it were the whole of it. Nice. I am opposing the basic views that have been shaped over 25 years ago when Max Born put forward his probability interpretation, which was accepted by almost everybody. I don't like it, and I'm sorry I ever had anything to do with it. Schrödinger. Quote from Schrödinger. And this is on the paper, The Interpretation of Quantum Mechanics, 1995. Dude regretted it. That's crazy.
That is crazy.
You called it, Stone. It leads you to drinking and all that shit. You just watch the world fall apart around you and just fall for this crazy nonsense. But let's see. So, and also Heisenberg wisened up a little with age and tells us that even major modifications, even major modifications of the present physical theory would not transform them into the desired new theory, as quite different and novel ideas are required. Secondly, the impact of quantum theory and relativity theory on the minds of scholars who helped found them in the first half of the century is conceivably such as they are imprisoned by such as that they are imprisoned by these theories, and thus they cannot help reason comfortably. That is in terms of traditional concepts, whereas the need for the whole of the revolution of thought, which can be carried through by nonconformists. Don't worry, brother, we got you. Dude, that's crazy. They literally post things like, how could you answer this without quantum mechanics and relativity theory? And it's like, how many times have we looked into it and it's never mutually exclusive?
Never.
It's always done through the presentation of some conditions imposed based off of a model to reify it, that only a certain math transcription can,
Yeah.
can make sense of it. And it's like, okay, dude, cool.
It's not only
you made-
usually not exclusive, but it's usually derived like after the fact.
Yeah.
Like it's like, oh, okay, yours guys' works. We already know your guys' works, but we're still gonna derive ours and tell you it's what's real.
After the fact, bro. Obviously, here we are left with the white elephant in the room, and we better address it. The reality of fiction of quantum computing. After what was said above, the answers should be self-explanatory, but let's go for it. Quantum computers also use zeros and ones of classical computers. But in the state of superposition, what Schrödinger has showed us to be utterly a ludicrous idea, and let's not. And Schrödinger wasn't wrong about that being utterly ludicrous. The modern quantum computers is a complete failure. They just simulate large data sets and then take like random samples from it. It's insane. And they act like they have this huge struggle. Like, we have to cool the computer to zero because superposition and ambient background temperature collapses the wave. So it's really hard. They haven't done it at all. It's no different from the old computing, and it's just more expensive and they more processing power. But it's not. They're not superpositioning anything. I seen your mic light up, Stone. Did you want to touch in on that?
Right, you see Stone light up, and you're like, all right, let's just give him like a minute just to make sure we're not missing some gravy.
There could be potential gravy. I see it's coming off mute, but there's no audio coming through.
Oh no, we might need to reset him again.
Morse code?
I'll move him and move him back. Stone?
Me now.
There we go.
Oh, there he is. There we go.
You hear us?
God, yeah, I can hear you good. Screw Discord, man. I hate these guys. What was I saying? It was, when we're talking about, don't forget the zeros and the ones, and they're a physical state on and off, and now they can be superimposed, and yeah. It reminds me of when they're auditing an election. Just take a few votes out of that box, a few votes out of that box. We know exactly what's going on in every other box.
They quantum counted all of the boxes, and that's how you know all the elections are super legit and official, because quantum mechanics is super legit and official, as we've just
they got
read.
it sussed.
Absolutely.
I'll
All
tell
right,
you
so
what.
they got this.
Oh, sorry, go ahead. Totally off topic.
No, you're straight.
I was just gonna say
okay.
those last 2 kilobits per second really make a big difference on the sound quality. So we're gonna try 13 here.
Nice.
Cool.
All right, so let's not is that what's happening?
I
Is
think
it bit rating?
I think it could be a bit rate problem. Yeah.
Yeah, because it only okay. So let's not see where were we at here. Quantum computers suck. They're fake. After what was said above, the answer should be pretty self-explanatory. But let's go for it. Quantum computers also use zeros and ones of classical computers. Oh no way. But in a state of superposition, which Schrödinger showed us to be utterly a ludicrous idea. Let's not forget that the zeros and ones refer to physical states of on and off. And now it is claimed that the physical gadget can be on and off at the same time, but you can't access it, because if you do, it will force a collapse in the superimposed state. That will mean that you'll only get one result or whatever. And you just have to believe it, and that's the theology of, dog shit. Okay, so here's a little diagram of a computer switch input. So we have on-off switch, and then we have, what is this? The logic gate. And then the logic gate, when it's when it gets the correct value, it'll turn on the light, right? So the main thing here is you can only send in 2 possible combinations at a time. And in this configuration, he's sending in 2 offs, but you could send in on-off, right? So you could send in 0, 1, you could send in 1, 0, just do all the combinations, basically. That's how it works. Now, what they're saying for quantum mechanics is that they're saying that they could send a 0 and a 1, and at the same time, all in here, and then it just magically will work out and the light will turn on or something. It's insane. But they don't do that, right? They still do 0, 1s, and then they just build a large data sample, and then they just use they just randomly select data from it, and they're like, oh, it's quantum weirdness, bro, in my floppy drive. Here it is claimed that 4 possible states arrive at the gate at the same time, but you can never know because, and by the way, so this logic gate that's measuring this that's not measuring this to determine if the light should turn on or not. It's somehow able to measure this, but not collapse the wave state to cause the superposition thing to fail. Whatever. Don't focus on that. It is claimed that there are 4 possible states arriving at the gate at the same time, but you can never know because you will always get 0 or 1 at the moment you try to access the information. By definition, the very theory poses, by definition of the very theory that proposes such devices. It cannot be overstated that Schrödinger's wave mechanic is not quantum mechanics. It is the opposite of that. What the quantum camp did is hijack Schrödinger's wave equation and pin it on their lapel, which is what Max Born did in his paper. Oh, here we
That
go.
would
The
be a
19.
lapel. Yes.
Oh, lapel. Thank you. Sorry, a lapel. That's dude. I kind of want to call it a lapel now, though, for good measure. But thank you. So let's see. Max Born, and this is what was this paper? This was on the collisioning. Hold on, let me get the title for you. That it really matters, but Max Born, yeah. So the quantum mechanics of collision processes and scattering, right? So remember how I said that they took it all back to...
Of course he has the paper.
They took it all back to, what's it called? Oh, the Compton effect to save everything, right? To say that, oh, well, only relativity and quantum mechanics and the description of the photon can describe this event successfully, right? And then that's how they got Dirac and company back on board. So let's see here, which we read in the interview from my last presentation on quantum mechanics. So we have abstract. Schrödinger's form of quantum mechanics permits one to define in a natural way the frequency of occurrence of a state with the help of the intensity of the associated...
That's an eigenfunction.
Oh, the old eigenfunction. Thank you. This understanding carries over the theory of scattering, where the transition probability is determined through the asymptotic case of aperiodic solutions. Someone is typing. Here we see him use the term Schrödinger form of quantum mechanics, which doesn't exist. Yeah. It is the form of Schrödinger's wave mechanic before presenting a third interpretation based on the idea that he got from Einstein that determines the probability of a photon. But Einstein has already shown how problematic it can be to apply statistics to physical systems in his paper about the Brownian motion. Oh, I've heard of this. Do you know about this, Stone?
First time I heard about Brownian motion was in an Adams novel.
Really?
I think it was So Long and Thanks for... Oh, wait. So Long and Thanks for the Fish? Or was it his detective series? What was that guy's name?
I have
Adams.
no idea.
I'll have to think more on that.
Yeah. I've heard of this before, but I never looked into it. I don't even know what Brownian motion is. There, he made the latent heat of the system responsible for the displacement of a particle through a viscous medium, which causes friction, the prime dissipator of energy in nature, without the system losing heat that is cooling. Einstein's probability approach thus cannot represent physical reality. If you would propose to a plenum of physicists that an explanation of any natural phenomenon that violated the way nature operates so blatantly, they would react adversely. To put it mildly, they would cringe and drive you off the premises with wet rags. Schrödinger reacts similarly to Born's hijacking of his equation to his paper here. So this is the exchange of energy according to wave mechanics. Here he is adverse to the conception. According to Born, the alteration of the probability field as time goes on is compulsory, causally controlled by the wave equation, and consequently, the alteration in time of probability amplitudes is controlled by the equation. Hence, the objection to reversal mentioned in section 3 now applies to the alteration in time of the probability amplitudes. So far as I can see, we can therefore never reach a one-way irreversible course without a supplementary hypothesis about the relative probability of various possible distributions of the initial value of the probability amplitudes. I am adverse to this conception not so much on the account of its complexity as on the account of the fact that a theory which demands our assent to an absolute primary probability of law of nature should at least repay us by freeing us from the old erotic difficulties and enabling us to understand the one-way course of nature process without for further supplementary assumptions. So yeah, he was that was him being adverse.
You
That's
know what
the
he means
most-
by ergodic difficulties?
No.
As in, something happens, therefore ergo. That's the Latin, ergo, therefore something else. Conclusion. You know what I mean? This is dynamics he's talking about.
Oh, I see. So he's saying you can't just make the assumption that happened, therefore the reason we gave you is the explanation?
He's saying it's got to be either or. And if you're going to put in a replacement, you've got to have something that satisfies enough reasons to get rid of the old. And they never did that.
Gotcha. Yeah. Dude, I almost want to give him a shout out, but you know. In the original German, he uses the word Strudel, which is a tad more emotional than being adverse, which some would find cringeworthy. Nice. All right, so here we have him using the old German. All right, so here we have Max Born, one man's opinion on how one can force the idea of quantum particles into classical wave equations. Both quantum mechanics and quantum computing solely depend on this man, on the opinions which are expressed by this man, on the quantum mechanics of collision preliminary communication. So here's what quantum mechanics begins with. If one translates the results into the terms of a particle, only one interpretation is possible: the probability given for the electron. Oh, dude, I recognize this. So he meant to say that if you square the probability of it or whatever, you square the solution for that. That's why there's an asterisk there. So yeah, that's him just proposing it in his paper, like, hey, if you guys want to jump on board with this particle situation, we could square this wave solution. So this is the solution to Schrödinger's equation, and that's it. There's nothing else behind it. No science. It's just math. It is the opinion of Schrödinger's wave function that gives the probability for the location of the quantum particle. This is called the Born rule. There is no scientific hint or justification or proof that this is reflecting real physical reality. One asks how Born comes to this conclusion that there is only one possible interpretation, and that comes from trying to manhandle the wave function and force feed it into particles. Here we see two waves moving in opposite directions. So see, and here we see the superposition, which is a natural occurrence in wave mechanics and called interference. This is called constructive interference. Okay. So the waves, I thought he said they were going in opposite direction. Here we see them moving in opposite
so this
direction.
is frame 1 you're looking at, and we scroll down to frame 2 because you have two waves moving towards the center, and this is where they meet the center, and there is additive function.
Gotcha. All right. So yeah, that's what Stone just laid that out. So now we see that the waves as particles and how the two particles would occupy the same space and time not happening. Oh yeah. So yeah, if you imagine two billiard balls in here, right? And then when they collide, what happens? Where does the other billiard ball go? Well, they occupy the same space and time or whatever. One turns into a wave, one turns into a particle.
Amplitude is summed, and that's why you're seeing it above the line.
Yep. But the imaginary billiard ball in between here would be like the representation of the collision. Yeah. So let's see here. We have now. Now Now think about these waves as particles and how the particles would occupy the same space and time, not happening. So now you have to get creative and say, wait, these waves are not waving in a medium, but they're waving probabilities, and their probability amplitudes that interfere. That is not physics. That is that's not even a good philosophy. Dude, I love Brenner. And how the Bible exegetes force interpretations of scripture into the framework of wishful thinking. Man, what a G. All right, amendum. I have written about the Planck light quantum in another answer, but it begs to be mentioned here briefly because many associate Planck with quantum theory. In this equation here, energy equals hv, and the h is Planck's constant, and the f is frequency. This is not about quantum particle. It is a necessity of the time of frequency, a process and not a thing, which can be contained in a space frame volume. The equation describes 1 second's worth of energy process, and that of the oscillation of electromagnetic radiation. It's true. This is called I didn't go into it on the first presentation, but this is the quantum flaw. There is a fix to it, but they don't talk about it or address it or acknowledge it. But basically, this equation here is set to 1 second of time because what it's solved for was the black body radiation problem, which is for a 1 second interval, like that whole curve or whatever. So this is how this is. This is why it's locked to 1 second, right? So if you do things like shoot a laser at a certain frequency, right, for like less than a second, well, it shouldn't have oscillated enough to produce that wavelength, right? So you should actually see it in a different wavelength, but we don't. We see it like you turn on the green laser; it's always green. It's never like yellow, and then it has to turn into green.
It's brighter, is the point.
What's that?
It's brighter is the point when you're editing the amplitude. This is the empirical aspect of what we're looking at.
So this is this is like a separate thing for the timing interval for the frequency, for how they define electromagnetic radiation to 1 second. But if you yeah, but yeah, so there's some videos on that on ItsBS's channel, but I don't think we're gonna watch that, but I'll get the link real quick. Actually, it's on his Twitter. I'll have to find it here in a minute because he did like a special thing for that. But yeah, basically, it makes the wrong prediction, but they can fix it, but they just don't talk about it or acknowledge it because quantum mechanics is super legit skis and all that or whatever. So, all right. That was Michael Brenner's paper on
kicking ass.
Quantum mechanics. Is it useful and real? Does it mean anything, or did some guy just square in somebody else's equation? Comps. There we go. Let's see how long we live.
Going for about 2 hours. In no rush to wrap it up, but I'm also, whatever everyone's comfortable with, basically. I know Quinn kind of mentioned he wanted to read one.
Yes, and my friend came over, but he left in time. If y'all are still going, I can find a short one too. But
yeah, no, whatever you want to do, we're down.
All right, cool.
Yeah,
give me a second to get on my computer. It'll work better.
All right, cool. I'm gonna go grab our water real quick, and I'll see you back in a couple minutes.
Cool. So yeah, I guess while we've got a couple of seconds here, I'll just mention that if you don't already know, on Tuesday, Shane will be debating Ozian on Jeranism's Debatism platform. And they're going to be talking about electrostatics, and they're going to be talking about the ether, as well as probably eclipses and a few other topics. So we'll see. I don't know how many topics they're going to be able to really squeeze in, but so that's going to be going on Tuesday at, I want to say 8 p.m. Eastern. I cannot recall. Or I can check here. 9 p.m. Eastern. Tuesday, 9 p.m. Eastern. And we're going to watch it live here on Aether Cosmology in the Discord. We're not going to be live streaming that, but we're just going to be watching it. You can live stream it on Debatism. But then afterwards, we are going to live stream I'm presuming somewhat brief after show, but we'll see. Wherein we'll just keep notes during the debate, and that way if there's things that we want to clear up that maybe got passed over quickly, or that if Shane pops in and he wants to clear anything up, or anything just that we all want to chime in with pertaining to the debate, we'll do that at that point. And then also on Monday, I believe we're going to be doing another Twitter X Space. I think we're just going to do kind of an open, so that'll actually be tomorrow. We'll be doing an open Q&A, just kind of, bring your own questions about flat Earth or geocentrism or the ether or, whatever, cosmology space. And we're going to kind of free flow on that. So that's tomorrow at 8 p.m. Eastern on Twitter X Spaces, and we'll also be live streaming that. And then Wednesday, I believe there's going to be a presentation given regarding the analysis of historical timekeeping methods and calendar systems. So tune in for that. I believe Shane will be live streaming that, and that'll be on the ADL platforms and possibly other platforms as well. But yeah, so that's kind of just a little look at what we've got coming up. And then, of course, don't forget to look at the sun tomorrow and watch it and get occulted. And yeah, that'll be fun.
Nice. I'm back.
Cool.
Does anybody know when Witsit is slated?
For what now?
For InfoWars? When's he slated to talk to, what's his name, Harrison?
Oh, I
That's a
don't
good
think we've heard anything back yet, or other than like the.
Okay, fine.
Yeah.
Yeah,
That's gonna be dope though.
That's gonna be awesome if it actually happens. I wouldn't be surprised if they end up backing out.
Neither would I.
Yeah, there's no way it goes through, man.
It seems super unlikely, but
Dude,
it
it's
would
like
be pretty massive
when
if it happens.
I had that guy agree to come on in the field before he looked into it. He was like, "Yeah, I'm down. We'll do it this Friday." And he's like, I think it's best if we part ways."
or the nuclear plant has emergency. It's right at 7 p.m. Gotta go head up to the nuclear plant instead of coming on Ether Roundtable. But, that's how it goes.
Nuclear physics is hard.
Well, cool.
So, did
Guess we're waiting
Brandon
on
come
Quinn
back?
still.
Oh, why do I think his name is
I
Brandon?
am almost there.
Nah,
2
you're all
seconds.
good.
It's like taking a minute.
I may, let's see here. If there's another short one I could pull up.
I could do another one if you want, in the meantime.
Oh, Stone, if you want, that would be
Oh,
fantastic.
you're a G Stone.
Dude, you missed. Stone gave Piezo a good run for his money when it comes to Brenner reading.
Really? Dude, that reading that Piezo did the other night was phenomenal, bro.
Yeah, you haven't seen Stone yet though.
Has anyone done? Because I've been busy working and driving, but has anyone done What is Counter Space yet?
No.
Dude, that'd be a great
No.
one. Stone is a counter space lad.
I actually,
I mean,
have a
do
third
you
one
want to
lined
read
up,
it
but I
then?
didn't
If
mention
you,
yet.
I was gonna say, do you want to read it if you wanted? If you're like on that point, I can
I think I'm
wait.
going to
I
cover
don't
counter
mind.
space and the one after the one I have in mind. Yeah, no, that's
Okay,
that's
yeah.
Well, let me do one, and then
Oh,
you do one,
snap.
and then I'll do one. How about that?
No, you
Ooh,
said
I like it.
Does that
after.
sound
You
good?
go ahead and go first, bro.
Okay, cool. So
If you
it's
want
in the
to. I
Brenner
mean,
Comp package, and it's the one titled "Moon Landing Problems."
Ooh, okay.
oh, that sounds good.
And it's only 4 pages, so it's a nice short one.
Maybe a full moon, maybe a full eclipse. We'll see.
Yeah. Okay. The ODT is titled "Moon Landing Problems," and the key line on the top is, "Did NASA fake the moon landing? If so, how can you tell using the images?" You ready to go there, Toby?
Here we go. And the rover on Mars? Yeah, right?
Shout out to Ingenuity.
No,
Does it start with there are no real
no,
photos from outer
this has
space?
nothing to. No,
Oh.
no. This is in the Brenner docs zip file, the one that's posted in AC
All right, all right, all
down
right. Let
here
me pull it
under
up.
underneath roundtables into the docs folder. Yeah, that'd be the fastest way to find it. Otherwise, I could just drop it. I mean, hey, hold on a second here. Here's a faster way to do it.
I mean, I was having decent luck using pre-search. Well, let me just pull up the ODT files.
There we go. It's posted in the chat.
Oh, thank you, sir.
You bet.
The heck?
I think I'm turning Japanese. I think I'm turning Japanese. I really think so. Those are some very Japanese looking waves.
Why does it not want to open?
Oh, maybe because I saved it in my own version of OpenOffice and it doesn't like you anymore? That's a possibility. You might
Hold
really
on.
actually want to get it out of the Brenner Docs folder there.
Hold on. I got it. Open Sesame. All right.
Good try. I think it almost worked.
Appreciate your enthusiasm.
What are the what is the first what are the first like 5 words of the sentence of the first sentence?
Oh, first one is, did NASA fake the moon landing? If so, how can you tell using these images? That's line 1 in the doc. And the doc's title is Moon Landing Problems. Yeah, I could just print it to PDF just as fast. Give me a sec.
Is the one you're trying to get to, is it in Earth Awakenings or
Oh, I should
is
grab
it
it
like a
from
new
there
one?
probably. Or
I was just wondering,
I don't know. I really don't know because I've just been going off of his
It's right
actual
in the,
Quora profile.
if you scroll down in the Aether Cosmology tabs down on the left, it's after Roundtable into the docs, and then there's the Brenner's Comp folder. But that's where you'll find it. But I've just
I
created
got
a
a
PDF. Let me grab it here and drop
question
that into.
for
Oh,
whoever.
here it is. My bad.
Okay, so in Earth Awakenings, there is the Brenner Comp section, and all of a sudden there's this deleted user instead of a new perspective user.
That was
And
probably
Oh
from
yeah,
before. He probably it was probably old profile that got bombed.
yeah.
or
You got
yours?
Okay,
Oh,
there's the
okay.
PDF in the chat.
I see. I just saw I know
Yeah.
New Perspective put a lot up, so
I think
Oh, yo, Toby, can you post a link to Discord in the YouTube chat and mod me in your chat?
post the link to Discord in the YouTube chat and mod you on Aether
Yeah.
Cosmology.
Yep.
Yeah, give me a second. Hold on. That's
Yeah, I was trying to link it and I just realized
That's
that nobody could
asking-
see it because it's a URL or whatever.
that's asking me to be a parallel process worker.
Oh,
So for some reason,
Okay, there's a PDF in the live chat now.
yeah, thank
Okay.
you. For some reason, OpenOffice keeps crashing on me. It looks like so. Thanks for being patient, everybody.
It's probably a version conflict.
There we go. There we go. I'm streaming, and then also I will go ahead and make you a mod, Alan, and post a link to the Discord. So yeah, are we gonna? Who's gonna read this one?
Yeah, we're set to go. All right. Did NASA fake the moon landing? If so, how can you tell using these images? It's primarily a question about why NASA and the astronauts they trained, to their level of understanding, are telling so much blatant nonsense about space. The rest follows from that assessment. You don't need to have been in space to know a few very important things about it because you use space on different occasions here on Earth in your daily life. Take the double-walled thermos you use to carry your hot coffee to work every day, for instance. It stays hot because you have a little bit of outer space around it, a vacuum, the best freaking insulator you can get. Space is not cold. Temperature is a property of matter. No matter, no temperature. Full stop. Space is the ultimate insulator. The only way to lose heat in space is radiating off heat, but not conducting off heat. So wrapped in a thermal blanket, which you can get at any outdoors retailer, you could float happily and comfortably warm in outer space. Well, except for minor details like lethal radiation and pressure issues. But NASA doesn't seem to know. Oh, it doesn't seem to know that, and therefore it doesn't keep their astronaut actors from telling nonsense stories like not having been able to sleep in the LEM because it was so damn cold, which would be equivalent to telling to somebody not to have been able to take a nap in his car parked in a shadeless parking lot in southern Florida because it's freaking cold. The parking lot on the moon kicked that experience up a notch to 273 degrees Fahrenheit. Quote, Aldrin tried to curl up on the floor of the LEM only to discover that he was too elated and also too cold to sleep during the astronaut's scheduled 7-hour rest period before lunar takeoff. As he reported afterward, the thing which really kept us awake was the temperature. It was chilly in there. There you go, small Paul.
Hold on. That's
You all
so
right?
absurd.
Dude, he was too
It
elated
was
and
just
cold.
chilly in there.
Just so cold, man. Just so cold, but we made it.
Next thing NASA misses to teach their actors is a little bit of seamanship. This is a spaceship, after all, and they happily use nautical language because that's what the audience of the spectacle expects. They didn't just bother to get the details right. Michael Collins, navigator on Apollo 11, and I quote, swinging the sextant around until it points at where it thinks Menkent is. Aha, there it is, in plain view. And it's a simple task for me to align the crosshairs precisely on it and push a button at the instant of alignment. End quote. A sextant is an instrument that uses mirrors mounted on a calibrated movable leg. The essence of the instrument is to superimpose one object over the image of another, thereby measuring the angle between them or between object and horizon. Which horizon exactly in space? And yeah. And there are no crosshairs in a sextant. It's completely worthless in space. This from a chief navigator. That's like a concertmaster of an orchestra telling the audience that the clef tells him the rhythm when in fact it gives him the tonality. For the modern atonal piece they're about to play, just gibberish. And I would actually correct. The clef is actually telling you the range of pitches the instrument you're about to play is in relation to middle C. I think he's talking about the key signature that tells you about the tonality or the tonal center if you're dealing with diatonic scale construction. But I digress. Talking about navigation. It seems NASA made their actors watch a lot of Star Trek to get them in the mood for acting out space travel. And in Star Trek, spaceships orbit planets nose first, because that's how an audience whose acquaintance with Newton is generally by name only expects a vehicle to behave. Quote, and there we were, two dead vehicles captured by gravity in a vertical position going around the Earth. Lovell and Aldrin after detaching from Agena. Newton would beg to differ, though, because an object does not keep attitude relative to space and not relative to the body it orbits. Oh, does keep attitude relative to space and not relative to the body it orbits. Keeping attitude relative to Earth means reorient in space, and that needs acceleration. Rotational acceleration, guys. It needs firing booster rockets, which is never mentioned. And that's not called being in orbit. That's a flight. The sequential sunrises the astronauts are always raving about would only be possible to observe in flight, not in orbit, because half the time the nose, where the windows are, would be oriented away from the sun and Earth. Quote, the control room people exhaled with an audible sigh. Conrad reported that his instruments showed Apollo 12 to be in a 170 by 61.8 mile orbit. Earth radar refined this to 168.8 and 62.7 miles nautical. Of course, an audience who doesn't, let me check my mic level, oh, still good. An audience who doesn't know Newton from an apple has no chance of catching the nonsensicality of this statement. A radar beam at the distance of the moon has spread to almost 3,000 miles, which makes it impossible to pick out the speck of an orbiting capsule at 60 miles distance from the surface of the moon as it appeared on the CRT, the cathode ray tube of the operator on Earth. It would have made a blip about 3/1000ths of an inch away from the background bounce that represented the moon. Good luck, Mr. Operator. Why all this nonsense? And we haven't even gotten to the images. In our days of Photoshop proficiency, a 10-year-old can pick out the fakes in seconds. It's so ridiculously amateurish, it's offensive. What with shadows in all directions cast from one light source, shadows missing, absent exhaust craters in the powdery dust of the moon's surface, plastic antennas still intact after going through the hell of re-entry, creases in a pressurized spacesuit, vehicle parts superimposed on range-finding crosshairs of the camera. How do you get that? And on and on. Here's one of the most offensive to anyone who's little more than awake than brain dead. Collins, again, in Carrying the Fire, claims that the picture is of the Sea of Tranquility and shows the landing zone. The shadow in the lower left corner is supposed to be from the engine shroud, whose diameter is 8.5 feet as it orbits 79 statute miles above the moon. Commercial airliners 10 times as large do not cast definitive shadows from 30,000 feet, which was like 5.5 miles, just for comparison here. And yet, here we have an astronaut putting his name under the lunatic, as it were, claim that a nozzle casts definite shadow on a surface 79 miles away. What a wondrous placed that moon is. I'm not quite sure where he's going with that statement. When your boys come back from a weekend where they were supposed to do Boy Scout stuff, and of course what they did was getting wasted in the club, but what they give you is fake Boy Scout stories, you will know. And you will not ask them if they've been doing Boy Scout stuff. What you'll ask them is, why are you lying to me? And then we look at the three boys right when they come back to Earth for the victory press conference. And look at that. They're so happy. They're the first three guys to get there and back alive. You don't need to have a PhD in psychology to read that body language right there. Here endeth the doc.
That's a good one.
You're great read.
Yeah.
Dude, yeah, it's just chilly on the bottom of that spacecraft, but, you know, a
Thanks,
couple
man.
space blankets,
I just
no
can't
biggie.
sleep.
It was very chilly in there. This is so absurd, man.
It's hard to sleep, bro.
They got us so good.
You mean
Well,
all that foil didn't keep the heat in? Oh, wow. But my Hot Pockets have no problem doing that with foil.
shadows in all directions cast from one light source, shadows missing, absent exhaust craters in the powdery dust of the moon's surface, plastic antennas still intact after going through the hell of re-entry, creases in a pressurized spacesuit. Vehicle parts superimposed. I mean, yeah. Why do we
Delightful.
trust them? I don't know. Because they're government. So yeah, did you want to read that one then, Quinn?
Sure. Yeah.
Cool. Whenever you want, you can go for it.
All right, 1 second.
And if you want, I have it pulled up on my screen if you'd rather read that. However you want to do it.
Yeah, no, if you're gonna keep up with it the way you have been, it seems like it's all right.
Yeah, can do.
All right, there it goes. What is counter space? In order to make any sense of the term and the concept of quote unquote counter space, we first need to be ready to free ourselves from deeply held but unphysical and nonsensical notions about space and time. That means we have first to erase from our minds everything we associate with Einstein and let instead Faraday, Maxwell, Heaviside, and Steinmetz guide our thought process.
Drop Einstein. Check.
What is a dimension? There is a difference between a physical dimension and a metrical dimension. I feel like you might mean metric, but one has a physical reality, the other has not, and exists only for the purpose of qualifying physical dimensions. Space is a metrical dimension and is one, not three. The three being the result of a choice that of an orthogonal geometry. Any number of coordinates in any number of geometries can serve to define the boundaries of space. The use of the cubic 3 is habitual. Qualifying space is multiplicative and done in powers of a unit space dimension, let's say centimeters. We have positive powers and negative powers, the positive powers being length in centimeters, area in centimeters squared, and a volume of centimeters cubed. The negative powers being span, 1 centimeter, density 1, I guess, is that divided? Centimeter
Yeah.
squared.
Yep.
It's
Concentration.
1 per centimeter, 1 per square centimeter, 1 per cubic centimeter. Yeah.
Thank you.
Oh, I thought it was divided.
Okay. Yeah, I wasn't sure. I know that sometimes mean division, but the positive powers of space are called conventional spatial relations, or simply spatial relations. The negative powers of space are called counterspatial relations, or counterspace. One, time is another purely metrical dimension. Here again, only to qualify, if space is multiplicative, time is additive, represented by a number line. We can move forward and backwards along this line while the motion of quote unquote per time 1 second represents a cycle or frequency, being f. What are physical dimensions then? Let's say we have a carton of milk. Then the milk is the physical dimension, whereas the carton is the metrical dimension of the bounding space. Milk, as such, has no boundaries. Milk, as such, is not quantified. When you want to make cheese out of milk, you add the linear metric dimension of time. Now, with Einstein, the 20th century has relapsed into primitivism of Newtonian billiard ball physics, totally ignoring and positively denying the fundamental insights of our electrified civilization. Harvesting the fruits of these insights, yes. Understanding them? Nah. The primordial physical dimension is unbounded ether, the polarization of which creates all and everything we see and feel. The ether, as such, has no duration and no extension, doesn't know space nor time. Quote, time and space is not nature which imposes them upon us. It is not nature which imposes it upon us. It is we who impose them upon nature because we find them convenient. H. Poincare. It is the polarization of the ether which creates everything, and this polarization plays out between space and counterspace. This polarization is called the electrification of the ether, where magnetism lives in space, whereas dielectric lives in counterspace. Here we have to jump across a counterintuitive canyon. because both space and counter space are positive, inclusive quantities. The more space, the more stuff you can store. But counterintuitively, also the more counter space, the more stuff you can store. For the electricity extent between a pair of wires in your lamp cord, the closer the wires, the more the capacitance, C in farad, and thus more dielectricity. The further away the wires, the more inductance, L in Henry, and thus more magnetism. Therefore, the smaller the space, the more counter space, the more dielectricity can be stored. And conversely, the larger the space between the wires, the more space, the more magnetism can be stored. In order to truly appreciate this, we have to let go of other prehistoric superstitions. As C.P. Steinmetz called it already in 1900, the idea that electricity moves in wires, it does not. The electricity is an induction process in time and not a movement in space, and it takes place between wires in the dielectrum, not in them. Wires are only waveguides, conducting only because they resist penetration, like fences resisting the passage of sheep, for instance. Superconductors allow an almost zero penetration and therefore an almost frictionless guidance. Wires got hot because of the sheep rubbing along the fence, not because the sheep moving inside the fence. It is basic concepts of J.C. Maxwell that the electrical activity is contained solely within the dielectric medium, i.e., the insulator, not within the metallic portion of the geometry which bounds it. It is important to understand that the dielectric and the magnetic field are force fields, exerting actions so as to increase their coefficients of induction. That is, the dielectric capacitance and the magnetic inductance are increased. The dielectric fields pulls the conductor together, increasing counter space. The magnetic field pushes the conductors apart, increasing space. The dielectric field is conductive, and the magnetic field is expansive. The total electrification of the ether, Q, in Planck, thus is the product of magnetic induction. In Weber, associated with the metric dimensionality of space and the dielectric induction in Coulomb, Coulomb?
Yep.
Associated with the metric dimensionality of counter space. Q equals
Phi times psi.
phi times psi. Thank you. The quantitative aspect of a medium with respect to capacitance, dielectricity, and inductance, magnetism, is expressed in factors called permittivity as a factor of capacitance and permeability as a factor of inductance.
So, permittivity is epsilon, and then
That's actually
permeability.
permittivity.
Did I say that?
Permittivity.
Permittivity. Oh,
That was
really? Permittivity. Hey, dude, I've been saying I've been saying it wrong. Permittivity. Okay. So that's epsilon, and then permeability is mu. So that's So that's for the magnets.
What was the word you said? Nu or mu?
Mu.
Mu.
Mu. Ah, like the island of Mu.
Yes, sir.
Mu in Henry cm and epsilon in Faraday cm thus represents the dielectric and magnetic inductivities of the medium bounded by the metallic dielectric geometry. These can be seen as gradients characterizing a medium, like the resistance to a measles infection of a certain population. It is obvious that without a population, there is no infection. Similarly, without a medium, there is no inductance gradient, or mu, nor capacitance gradient, epsilon. Talking about mu and epsilon is a vacuum is therefore complete nonsense. Because electricity is not a thing but a process, we need to look at the time variance of these primordial physical dimensions. Dielectricity and magnetism, like milk being a physical dimension, but now we are looking at making cheese, which involves time. The rate of change in time of the dielectric induction, whatever those
Psi
are,
Psi
over
over T.
time.
psi over time, or the time rate which the dielectric induction is produced, consumed, is the displacement current I, and expressed in what is called the Maxwell law of dielectric induction. I over psi over, or I equals psi over time in ampere. The rate of change in time of the magnetic induction being
5 over time.
phi over time, or the time rate which the magnetism is produced, consumed, is the EMF, or electromotive force, and expressed in what is called Faraday law of electromagnetic induction.
My
E equals
favorite.
phi over time in volts. I'm sorry?
Stone's favorite.
That's my favorite.
The total electric activity thus is the product of Weber's and Coulomb's, giving us Planck's over S
Planks per second squared.
Yes, you got Webers per second, coulombs per second, giving you the Planck per second squared.
or the electric power P in watts. Q over T squared equals phi over time times, or a
Yeah, you got it.
psi
Yeah.
over
Yep.
time equals I times E equals P in watt. Or Q equals P times T squared in watts times S times S. Thus, the total quantity of electric induction, i.e. the total quantity of electricity, is given in watt times seconds. And that means that the variation in time of rate of change, the time derivative of the total electrification of the ether, is energy. Q over T in W times S squared over S equals W times S over J. I'm not sure what to call the
Equals the
parentheses.
joules.
Equals.
Equals, okay. 1 watt times second is 1 joule, the unit of energy. That means energy is not a primary physical entity. It is a time derivative of the electrification of the ether. It is not a fixed quantity of which the universe has only so much. Energy is a result of
Yeah.
a process in time and has absolutely nothing to do with mass. E equals mc squared. In an upside down way, does have to do with C, though that is via the magnetic and dielectric laws of proportion and the magnetic and dielectric gradients of
Mu and epsilon.
epsilon and mu and epsilon. Thank you. I couldn't remember mu. Law of magnetic proportion, Weber ampere times Henry. Law of dielectric proportion equals Coulomb time volt times Farad. Weber times Coulomb over cm2 times 2 equals V times A times mu equals times epsilon, and that gives the same as Planck over centimeter squared equals Planck over second squared times mu times epsilon, and gives us S times 2 over cm squared. S squared over cm squared equals mu times epsilon.
Boom.
Holy crap. So much respect that you guys sit there and read the papers saying all
Well,
that
so
shit.
yeah, I guess there's still 2 more paragraphs here.
Oh, there are. I'm so sorry. I thought.
No, you're good. I did caught me off guard too.
Yeah, go for it, man.
The product of the magnetic and dielectric inductivities comes dimensionally in time squared over distance squared, and that has been written as 1 over c squared. And from that, through mathematical transformations, one has arrived at c in minutes over seconds.
Meters per second.
Meters per second. But we can see that this is fallacious because nowhere here do we encounter a displacement of space per unit time, which is what a velocity is. There is no physical reality that can be called, quote, speed of light. The underlying physical realities are two induction gradients. Furthermore, this is strictly a characteristic of the transverse electromagnetic waves, so elevating an incorrectly derived quantity with a limited domain of validity to universality, and on top of that, call it a universal limit of is total bogus, and a cosmology built on it can only be called ideology, not a valid description of the world. Now, I gotta say, that
Booyah.
last paragraph is
Well
just
said.
like, well, it's like you could turn that into a little rap, you know? It's like,
Yeah.
where was it? The quantity of the limit of domain of validity to universality on top of, which is great.
Yeah.
Thanks for helping me. I'm sorry, I don't know what you know.
Oh, you're good.
I
bro.
think you
killed
did
it.
well.
Dude, you did great.
Right.
And like literally, I sounded exactly like you, like less than, I don't know how, only a few months ago. So no worries at all, dude. Like I still don't know all my Greek variables and stuff myself, and I read these papers all the time. So
Man, it makes me want to get on Duolingo and learn Greek or something. Seriously, like, why not?
That's the first comp I made, by the way.
nice. That's a good one. That's a really good topic, and he has a surprisingly broad depth of knowledge on that one as well.
Yeah, hard to even translate.
New perspective. Did you get deleted? Did your account get like bombed?
Why?
Oh, I don't know, because I was in the Earth Awakenings and I looked in the Brenner compilations and there's this deleted user who posted
Oh, yeah.
all.
That
Yeah,
was
so
way
I was
back.
like,
That was way back when ADL went down.
oh, never mind then.
Yeah, I posted all those before ADL went down.
So yeah, did anyone else want to read one? Should we wrap it up? We have been going for 2 hours and 40 minutes now. But I don't know. Did you want to read one, Dave?
Someone else can. I'm kind of
Oh
actually
yeah, no
about to go
pressure, no pressure. Should we? I mean, we can go and wrap it up. Honestly, we've been going for a couple hours. Unless anyone else wants to do another one.
I got a long one, and I'm kind of surprised nobody picked it.
Do you
It's
want to
on
read
Ether.
it?
Let's go, Stone.
Let's go.
It's okay. It's 16 pages long, so we're going to start on page 5 because
Okay.
he starts a lot of it with quotes of what other people think Aether is over the time, over the
This
history
one.
of man, and
Is it What is
you know,
Ether?
we don't- yeah, it's just titled ether.odt in the comp in the zip file. I could just throw it in the chat here if you like.
Yes, please.
Yeah.
'Cause I don't have that one. I'm not familiar with it.
There you go. And again, I've edited this one. You might not be able to open it. I think I'm going to have to pull it out of the
Ooh, yeah,
the
you
zip
have
file
this.
again.
I might have.
Oh, let me make the PDF. That worked for you guys last time, didn't it?
Yep.
Yeah, let me get that open. Hold on. One sec.
So... Right.
16 pages.
Yeah, I love these Brenner comps, man. Like, I don't know. Have you recorded any of this?
Oh, this has all been live. We're live right now.
Nice.
By the way.
Yeah. So I love these things. So this is great. You're getting so many, and you can take this one and break it up, take parts out you don't want, and if you know, I know you have a lot on your plate, Toby. I'm just saying.
No, yeah, I
Right.
think with this one we're just gonna. I mean, I think I'm just gonna. We'll probably do a few more of these. Put it that way. Until we can
That's a
get
good
Brenner
Okay,
to
it's
come
up
on
in the
and chat
live
with
chat.
us live. Cool. So I
The
got it
PDF
open.
is up.
Let me go ahead and share my screen, and then we can follow along here.
Awesome.
So you said we're gonna start on page 5. Okay. That seems like a good idea. Right at Mickelson Morley. Nice. Say whenever you're ready, Stone. Uh-oh, did we lose him again? I'm gonna...
Oh, no, I'm still here. Just got to
Okay,
hit enough buttons to make it happen.
cool.
Okay, so back on 5. I think I'm going to start right about full circle. So it's right after the Morley quote, the 2 points, mid-page. So here we have come full circle. The
Cool.
concepts of space and ether have merged together. But how exactly? And what language do we use to describe that? First, we have to define ether itself, or rather, it is much more compelling to define what ether is not. And this is also one of the larger reasons
One
why I
second.
picked
One
this
second.
page. This
Your mic's kind of peaking a bit, and it's staticky.
Oh, it's too loud?
Yeah, a little bit,
Too
yeah.
loud?
Yeah,
A
and the
little too
static.
loud. Okay, well, I will talk not quite so loud then, because I'm liking the gain. Okay, so ether is not a substance that permeates space. Space itself is not an autonomous container within which the universe plays out, but itself a modality, an after effect of ether polarization. Being not a substance, it follows that ether is not physical in the same way as fire, water, earth, air, just the way Aristotle figured. It is asubstantial, and that means it has no Cartesian nor temporal measure, i.e. no location, no extension, no duration. What it is pure incommensurable potential. Ether is the antecedent to energy, which manifests as the time derivative of electrification, i.e. polarization of the ether, W. And this is really the value that's representing the work being done by the energy, being phi times psi or T. This immaterial, i.e. non-physical character, is what Tesla meant when he said, the day science begins to study non-physical phenomena, it will make more progress in 1 century than all the previous centuries of its existence. Okay, moving to counter space. Because ether has no Cartesian measure, no Cartesian location and extension, it can also not be part of Cartesian space. And its capacitance, therefore, cannot be measured in spatial dimensions. Dielectric capacitance is antispatial or counter-spatial. That may sound exotic, even esoteric, as T. Hale calls it, but it is applied physical reality in every capacitor used in circuitry, with a pretty little picture. And that looks a bit like a motherboard, actually. There, a big CPU in the foreground, where you would put the CPU on the mount with the clamp. So yes, that's definitely what that is. That's a PC motherboard. Okay, the principle is the tighter you wrap metal foils, the more electricity you can store. That is, the more capacitance, which represents more storage real estate in counter space. But it is not the metal surface that carries the charge, as is erroneously held by atomists. It is the dielectric insulators, as we call it, like glass, transformer oil, air, cellulose, acetate, between the metal foils that stores the charge. And less of the between, the less of the between you have spatially, the more storage capacity you have counter spatially. And I would add here that it says that it is the dielectric insulators, and they mention the physical insulators between where you're storing the charge. And I don't actually agree with that. I believe it is stored in the counter space between the two Gaussian surfaces. What the insulator is doing here is preventing resolution of charge. It's preventing the arcing. It's providing a higher insulational value than air in these little caps. You see these cans up here, the electrolytic caps in the picture, rated at 6.3 volts each. It is actually in counter space, in the space between the plates. And in this case, we're just wrapping the foils together into a cylinder, you know, and we're tightening it into a can like that. It's close to what he's saying here, but not quite. That's kind of where I would draw the line. Okay, capacitance then is the threshold of a dielectric medium is able to absorb of units of dielectric conduction before discharge. And that's really what I'm talking about. That the medium can only hold so much before there is discharge. So what we're doing is we're adding to that ability to hold more with the insulator. Metal is never where electricity is. As little as sheep are in the fence, they run between the fences. Dielectric magnetic, as a material, the dielectric is what is commonly treated as insulator, the stuff between the metal band of the circuit. Yet is there where the magnetodielectric event plays out. And this is what I was driving at. The conductor, usually the metal bounding of the circuit, cannot be penetrated by electricity. Wherefore it conducts, like fences conduct sheep between them. The dielectric then is the primary half of the conjugate field modalities of the magnetodielectric field. And that's where we lose people. I can hear people going.
Yeah, dude, that's exactly what's happening. Reel me back in, bro.
I'll say it again though.
Reel me back
Let's
in.
back it up, because the
Yep.
dielectric then is the primary half of the conjugate field modalities of the magnetodielectric field. So it's half of the equation in producing what we call the electric effect. It's half of it. And it's the voltage side. And the magnetic is the current side. This is where he's going to be going next. The dielectric is ether under torsion. And this is the voltage component of the two conjugates. The magnetic is ether under polarization. Here below two conductors, as we would see in transmission lines, and that's the below image, with the dielectric blue, the magnetic red, fields between, around them, but nothing in them, not even on them, as Chucky Steinmetz points out. Many textbooks speak of the electrical charges on the conductor and the energy stored by them without considering that the dielectric energy is not on the surface of the conductor, but in the space outside of the conductor, just as also is the magnetic energy. And it is a crucial point. That is extremely crucial to the mechanism and where counter space comes into play. Okay, underneath, dielectric is the capacitance of inertial counter space, whereas magnetism is the manifestation of spatial magnitude and temporal retardation, phase and lag time, through divergent loss of dielectric inertia engendering volume, i.e. space. Space is the attribute of the magnetic, which is the absence of the discharge of the dielectric. And now when they say the absence of the discharge, this is when we're talking about an electrostatic situation, for example, between two Gaussian surfaces, that we're holding the energy in counter space between those two plates as a function of the voltage we apply to them and the area that they are and the distance they are apart. Those are the fundamentals of the equations I think we're going to see them pretty soon. Dielectric is the inverse of force, the negation of force, whereas force is the loss of dielectric, which is magnetism. Dielectric is voltage, like I was saying, current is magnetism. If we draw a horizontal line through the power lines in that image there, we get inertial plane, the block wall of a magnet, which has the same field geometry. Magnets, thusly, are dielectric machines, driven by the flywheel that is the dielectric inertial plane under torsion, and the stronger the magnet, the stronger the dielectric, not the magnetism. Therefore, it is somewhat misguided to call magnets magnets because it is the dielectric, convergent, accelerated towards inertia, erasure of space, which is responsible for a magnet's power, not the divergent loss of dielectric inertia, which is magnetism. Now that'll probably lose you too. You guys can read that one again on your own a few times. This is a long paper.
I will. I will.
Long. This is why I saved it to the end. I was hoping somebody else would read it. It struck me as thematically congruent with everything this room is titled in to begin with. Anyways, a magnet is a
Dude, I'm kinda upset
dielectric.
I've never seen it. I've never heard of it.
Awesome. I made the right choice then. A magnet is a dielectric accelerator, not a magnet decelerator. Electrostatics, here we go. When a dielectric medium reaches its threshold of capacitance, and this is what we're talking about over driving a cab, it discharges or grounds. It arcs into counter space, and that is always in the form of dendritic Lichtenberg figures, exactly like the lightning you're looking at here. Artists get creative with this principle. Here below, high voltage discharge art, and it is no coincidence that the topology of Earth in vast regions looks just like dendritic discharge patterns. You know, like trees and rivers, and it's everywhere. Capillary systems, it's in our bodies. This is what we look like. It's everywhere in structure, in physical matter. All right, below that, electricity is a circuit always composed of the conjugate, dielectric, and magnetic. Here is a good point to train ourselves not to think of magnetic attraction when we hear or read the word magnetic. Magnetic in ether physics means loss of dielectric energy, loss of inertia, creation of space, force, magnitude, retardation, time. In short, the space and the material world of measure and magnitude we experience. What seems to attract in magnets is, as we've already said, actually its dielectric and not its magnetic aspect. Force and motion. This is not Newtonian physics where force is a connotation descriptive of what something does. Here it is a denotation standing for what something is. Here the force vector is a three-dimensional S-curve rooted in counter space representing the loss of potential or energy of inertia and the creation of dimensionality, time and motion, so that we can say magnetism is force and motion. That's a very deep statement. And I guess it's the literalization of what I've been doing in the physical to do with Adams motor technology that you guys probably saw on Friday night a couple weeks ago when I brought my own work to the table. This is all about a magnet passing by a coil so that its lines of force are intersecting and conflicting and causing gradients in counter space across the coil itself, invoking the magneto-electric mechanism and produces dielectric out the conductors of the coil, simply because the magnet is moving. And this is what we're talking about here. The three-dimensional S-curve rooted in counter space, loss potential energy of inertia, and the creation of dimensionality, time and motion, so that we can say magnetism is force and motion. But it's motion in counter space, not real space. This is where this is all taking place. Okay, on the subject of inertia and acceleration, again, this is not Newtonian physics, so we have to widen our horizon beyond what we call space, which, as we've seen, is only one of the field modalities of the ether. Here, acceleration is meant as acceleration of space, not the acceleration through space. So we're talking about the difference between something like electromagnetic wave propagation through space. That is an inductive rate through space that we're calculating. It involves counter space, but it's movement through space. This is entirely the antithesis, if you will. It is the accelerated collapse of space towards ultimate rest. This relates directly to that spike I've been talking about, guys.
Well,
The accelerated collapse of space, in this case, what's going on along the axis of the coil that you've induced the dielectric force within, by applying voltage to it, creating the B field. And when you kill the voltage to it, there is the collapse of that B field towards ultimate rest. And it does it really fucking fast because there's no mass involved. And when we talk about the propagation speed of light, I think those two velocities tightly relate. Hope I didn't lose you guys on that one. It is the accelerated collapse towards rest, i.e. inertia in counter space, that is called charge, as opposed to the discharge of space in the process of divergent loss of inertia. Now he's talking about physical things, that is opposed to what we see. Discharge in space of physical things. Dielectricity is inertia and acceleration. Okay, charge and discharge. Charge is not an attribute. It is also not something you can carry or have. There's no such thing as a positively or negative charged particle. Thank God someone said it. And there's no such thing as a positive charge or a negative charge, as well as no particle to begin with. There is no spoon. What we're dealing with here are events. The event of charging, like charging a glass with wine, and the event of discharging, like discharging a bottle of wine, as in into the glass. We can see that dynamic aspect in the units of charge slash discharge. The coulomb is measured in ampere seconds, as in the number of amps in a second, in this case meaning 1 amp constantly delivered over that second. It means charge is not a property, but an action, like pouring a certain quantity of wine in 1 second. From the point of view of the bottle, it is discharging. From the point of view of the glass, it's charging. Charging is always counter-spatial convergence. Discharging is spatial divergence. And those almost sound synonymous, don't they? Just as a
Yes.
thought. In a magnet, the discharging and charging are superimposed. The charging of the bottle and the charging, well, the discharging of the bottle and the charging of the glass are happening in one and the same object. And that's why it sounds contradictory, self-contradictory. Discharging is the spatial, toroidal, divergent, magnetic aspect. Charging is the counterspatial, hyperbolic, convergent, dielectric aspect. And those are pretty graphs. Those are pretty graphs, and I don't necessarily subscribe to them. But
But are you describing a conjugate relationship?
Well,
Yes.
to me, the upper one looks like a standard dipole inverted field. You know what I mean? What you would expect to see around a dipole, but inverted. So the dielectric, I guess, effect only, and the bottom one does not. I think that's an entirely different geometry there, and I
Yeah,
wouldn't
that
even say
hyperbole. I think
toroidal.
it's supposed to be like a hyperboloid, but it looks a little bit fat.
Yeah, but I wouldn't even say toroidal on that one, you know?
It does.
Because
Yeah, it
with the
does look a
toroidal,
little
like the one
fat.
above, there is the zero moment in the center, just like the center of a hurricane, for example, rotationally speaking, inertially speaking. There's always that zero point in the middle. And there is essentially one in the lower, but I don't think it's the same geometry when you're blending two like that. Two polarities. Anyways, hey, what do you know? Vortex polarities. The poles of magnets are inverse spin vortices respective to each other on opposite ends. As the edges of each pole, we find centrifugally accelerating divergent flux as a part of the toroidal geometry of magnetism. And at the center, the centripetally accelerating convergent flux of the hyperboloid geometry of dielectricity. These vortices precess clockwise, what we call n-pole. Now this is, what he means is when you're looking at the upper one, from the top, you would be looking down north-south through its axis. And he says clockwise is what we would see. And I think that kind of jives with us as the observer inside the optical toroid in which we live on Earth here, looking up at the stars. When we look north, we see the other side of that, which is counterclockwise propagation. So they obey the same geometric rule, what he's pointing out here, just as a parallel.
Yeah.
So the polarity, that is, the poles, are not static properties of the magnet, but precessional directions. You can test that by exposing a cathode ray tube to the faces of a strong magnet and watch the image twist in opposite directions. Again, I think this is where the quantum mechanic monkeys get electron spin from. And I think they've completely hijacked the concept. Okay, you can also test the difference between magnetic and dielectric by taking a spinning gyroscope built from non-ferrous materials to the edge of a strong magnet. The flux there will stop the gyro within a few seconds, whereas a gyroscope placed in the center of a magnet will continue spinning undisturbed. The difference is that the edge is magnetic flux, which means force and motion, and the center, dielectric flux, which is the negation of force and the return of motion to rest. And that just makes geometric sense, doesn't it? Coherency. Before a cube of neodymium or iron boron is actually magnetized, it is just a piece of matter like any other with the same unpolarized gravitational characteristics. And after magnetization, it becomes a powerful magnet, that is, a powerful dielectric accelerator. Substantially, quantitatively, though nothing has happened, it is still the same piece of matter with the same constituents. The only difference is qualitative in the form of field coherency, and with it, polarization. This is something I was talking to some boys in another channel earlier today to do with the Curie point, and this thing people are propping up as more fear porn about the eclipse, and not even just the eclipse, but ubiquitously, people talk about this catastrophic pole shift that goes on Earth.
Every
Oh wow!
720,000 years or whatever they say.
Yes,
But don't worry, it didn't
how is
happen.
our...
It didn't happen last time. They know it happened a bunch of times in the past, but then the last time it was supposed to happen, it got skipped. And then none of their predictions about where the magnetic field is supposed to go ever come true, but trust them, it's going to flip and everything's going to go crazy.
Oh, the skip
Totally.
cycle.
Somebody in the chat pushed the question to the effect of, hey, what would it take to cause a pole shift? I mean, is this like physically possible? And I answered to the effect of, well, when we look at permanent magnets, although we can't confidently assert that it's the same physical process of generation of the magnetic field we experience on Earth. But when we take a permanent magnet, it's a question of how we make it. And he kind of touched on it here, but he didn't really mention the key factor, and that is the Curie point. When we take the neodymium or the ferric boron, or both, and sometimes you typically now with the cheaper magnets from China, they call them a neodymium ferric boron, the material is heated up past the Curie point after Madame Curie, and then it is cooled inside a magnetic field, properly oriented to however you want that to look inside the magnet. And as the magnet cools, again below the Curie point, those magnetic lines of flux are preserved in the material. And you're not going to get a pole shift out of that permanent magnet until you reheat it above the Curie point. So that's what I think about the odds of a pole shift on Earth, assuming the mechanics of generation are remotely similar. That
Yeah,
was
well,
my answer.
it's a very noodly mess of how they say it gets generated. That, and then they've got like 30 different steps they can take to try and mathematically circumvent what you just laid out.
Exactly. Everybody's got a good guess, and I don't think that's good enough. Anyways, a good analogy is coherent light in a laser versus the incoherent light of a light bulb. A 5-watt light bulb is not good enough to read, but yet a 5-watt laser will burn a hole in your retina, probably from a mile away too. Anyways, point source. Coherency is not enough, though, to fully describe the difference between gravity and magnetism, or the difference between ordinary light and a laser. It is the point source quality that makes a magnet, and a laser, a laser. An analogy often used in describing magnets is the combing of messy hair, bringing them into alignment. But that wouldn't do. Aligned magnetic domains would not make a magnet. What is needed on top of that is to have the aligned hair. These aligned domains come from one single point, making it a point source. But even a Cartesian coordinate point would still not be enough. It is in fact an incommensurable point source, which turns a lump of neodymium into a powerful magnet. Thus, a magnet is defined by its point source field incommensurability, which is nothing else but the observed fact that a source of a magnet has no specific Cartesian location, nor has it any kind of magnitude. Cut a magnet into 1,000 pieces. The block wall, the inertial dielectric plane, will always be where it needs to be, which is everywhere and nowhere. And when you drill a hole into the center of a magnet, there's no flux whatsoever. It is total stillness, just like the center of a hurricane. The source of a magnet is stillness, i.e. rest, i.e. inertia. In other words, the incommensurable ether. And that is why, of course, the ether cannot be found as a Cartesian corpuscular substrate through which things move. The magnetic part of a magnet is the loss of stillness, the loss of incommensurability, i.e. the creation of measure. That is the creation of dimensionality and temporality, and of the temporality of space-time. I'm getting distracted by this bug on my screen. Sorry, guys.
All good?
What we commonly refer to as magnetic attraction is actually the return of dimensionality and temporality into the incommensurable, the non-measure having. It is the loss of measure, the collapse of space back into dielectric counter space. And in that sweet, it just sounds so good to even say it. Die fly. He's not. Oh, man. Anyways, where am I? Therefore, a magnet is actually a dielectric accelerator and not a magnetic attractor. That becomes obvious when we realize that the stronger a magnet, the less magnetic footprint it has. The weaker its magnetic toroid, the far more powerful its counter-spatial dielectric hyperboloid geometry, which sits over either pole as counter-rotating vortices. And that's what you will see on the CRT when you hold it noon, with north pointing at the screen or south pointing at the screen. All right, to repulsion. We have seen that what we are used to calling magnetic attraction is actually dielectric in nature. It is dielectric acceleration. What is magnetic in nature, though, is magnetic deceleration. This is the only phenomenon where we see magnetism in action. It manifests as compound Aether torsion, which was voltage from before, if you recall, which results in repulsion equals magnetic force multiplication as opposed to attraction, a dielectric force negation. And I don't know that multiplication is necessarily the correct verb, noun, rather, implying a verbness, but it is the noun multiplication. Um, I think maybe even some might work better there, and especially in the context of what we were looking at regards Schrödinger and wave mechanics, approaching waves and the additive and the extra amplification. This very well could be a parallel process that we're talking about here. That repulsion is a magnetic force multiplication as opposed to attraction equaling a dielectric force negation. And I don't even want to address his geometry here. That looks a little screwy to me too.
Oh, well,
It
maybe
just,
we can bring him on to chat about it someday.
Because when we talk about permanent magnets and their lines of force, we always look at radial. We look at R. We look at the big roundy lines that come off of them. That's what the iron pyrites do for us, right? The iron fillings. When you throw them at a magnet
Yeah.
on the paper and
Yeah.
they form all around it, those are the lines, right?
Yeah.
But I don't see that geometry in this image, so I'll leave that alone. So let's go to the atom and what it's not. It's not things the way the atomists are envisioning them. They are processes. Magnetodielectric dynamics, which create energy only to dissipate it as space. This is the 99.99% of empty space within an atom as atomists describe it. But this space is what an atom does, not what it is. As in it takes up space in terms of its energy signature. And the space is, of course, the field, the repulsive field against all matter around it, which is how it defines its own space. And again, the atomists are the problem here because the entire Rutherford Bohr model should be thrown out. And when we do that, those people are just going to lose their shit. I'll say that much anyways. Magnetism is nature's fundamental force, and it is centrifugal. Yes, Heil, yes. Dissipation of inertia. It is thus force and motion. Space is not a thing itself, but as we can say, shadow is the privation of light. So can we say space is the privation of ether. And a privation cannot have a property, as Tesla points out. I hold that space cannot be curved for the simple reason that it can have no properties. Looking for ether in space is like looking for light in the shadow. And I think he's quite correct on that analogy. Light, illumination, and waves. Again, let's start with what light is not. Light is not a wave, because waving is what something does and not what something is. Einstein could have stopped there right away when he tried to pursue a wave of light in his thought experiment, and that is as silly a proposition as spatially pursuing a fever curve. He's referring to epidemic spread. Fever goes up and down in time, not forward in space. Oh, I guess that's in terms of one human experiencing a fever and then it goes away later. Yeah, that's a physiological piece. The fundamental misunderstanding was the downfall of science at the beginning of the 20th century. here below Einstein really believed, oh, below as in here below, really believed he could chase such a wave, and when he caught up with it, would see a wave frozen in time. That is utter quackadoodle because a wave travels through time, not space. Here below, the x-axis is the time axis, whereas the y-axis is magnitude. So a wave has a position and a magnitude in time. This is called a versor, as opposed to having magnitude and direction in space. This is called a vector. And that gets us to the next aspect light is not. Light is not an emission. Nothing ever emits light. What happens instead is that something gets excited, that is, alters its state of excitation, and that state of excitation changes in time, or over time, I think is what he should have used there for preposition. The time it takes for a fever to move through a population is called the rate of propagation and is 100% a property of the medium, not the fever. So the processing rate of what we call light is medium specific, not light specific. Light has no property that can be called neither a rate nor a velocity. It is entirely the medium that decides how quick a signal is processed. And this is why we have all these experiments sending light through water and moving water and that kind of thing, because we want to check how the medium is affecting rate of propagation, not are the photons colliding with the water molecules. Anyways, light is not, okay?
Thanks for the clarification.
Just
dude.
thought I'd
That's
point that out.
awesome.
A little extra color commentary there. Okay, light is not a duality of any kind. As such, does not exist within nature. Nothing can be its own antithesis at the same time. Again, it is the privilege of Einstein to cement a fundamental misunderstanding in science, and he could have known better. Would he have been better informed about what his predecessors and contemporaries already knew? Lord Kelvin already postulated that the longitudinal propagation of dielectricity, as well as its much greater rate of propagation. Now, what he means is its greater speed of propagation through counter space. He's pointing that light is not a limit, and I think we're going to get to that real. It sounds like that's where we're headed. That these electrical waves are condensational waves in the luminiferous ether, and probably it would be that the propagation of these waves would be enormously faster than the propagation of ordinary light waves. So I'm not so sure about that. I mean, he's talking about longitudinal modulation through a dielectric like we would do through copper. And actually, I take it back because it actually agrees with what Eric Dollard said about how LMD really does involve a different propagational computation away from the speed of light. That's why in lecture that people are corrected by Eric when they refer to the speed of light as a limit, an absolute maximum in any context. He says, no, it's not a limit. It's a constant. It's not a limit. And this is where we're pointing it out in dielectric propagation happening faster than light propagation. I think that's what he's drawing a distinction in. So that gets us to what light is, finally. What we call light is an attribution of light known as illumination. Light is invisible. What is visible is illumination. Light is a dielectric longitudinal coaxial circuit with transverse electric and magnetic field modalities. Does that sound like Whitsitt or what? The power of light is not in these transverse fields, but in the longitudinal pulsations. That's where the capacitance resides, and thus the power of light to do harm. A gamma ray has a small transverse, that is EM footprint, but it delivers a punch, and that punch is in its longitudinal dielectric aspect, its capacitance. And again, it was Einstein's privilege to get it totally wrong when he called these punch-carrying longitudinal pulsations light quanta, light particles. Boo! They are not. They are not! Yay! Yay! They are not! They are a longitudinal field modality of ether perturbation. Yes. Breath of fresh air. Okay, the photon. A unit of light is the typical creation of atomists and mathematicians who can't help themselves but quantize and count everything. If they can't count it, to them, it's not real. J.J. Thomson already understood the photon as the intersection between magnetic and dielectric induction, or rather the longitudinal pulse that engenders the transverse electric and magnetic field modalities. That's another good one right there. Hopefully you guys can hear that.
That is a good one.
So, if you want to visualize something along these lines, think of holding two long broomsticks in your hands, such that they cross each other. Now rotate your arms outward and watch the intersection move away from you longitudinally, as in you're going to have them crossed in front of you and then both pointed straight ahead of you parallel. That's the motion where the tips move away from each other. Your hands remain the same distance apart. So rotate your arms outward, watch the intersection move away from you longitudinally. The intersection of those two broomsticks is not autonomous entity. It is an attribution of crossing sticks. That's what a photon is.
Yo, thanks for
Electron.
the extra context there, Stone. That was perfect explanation.
My absolute pleasure. We love clarity. In the same sense, electrons are not autonomous entities. They are only attributions of other entities. This was again known by the discoverer of electrons, J.J. Thomson, who likened them to the broken ends of spaghetti, or rather, 1,000 such ends constitute one unit called an electron. Tesla was the same opinion. I hold it that the electron is a relatively large entity carrying a surface charge and is not an elementary unit or particle. Oh, isn't that fun? Yeah, baby. Already in 1900, Steinmetz called the notion of a charge-carrying electron prehistoric. Oh, finally, when I was reading those last two sentences, I had a thought, and then it went away by the end of the sentence. So let me put it back in about them, the broken ends of spaghetti. I don't think that's right. This thing that they are attributions of other entities, I think that's close. When, I don't know, even 15 years ago, when somebody asked me what an electron is, in the dielectric sense, in the context of holding a charge, which is the thing upon which all of our electronics is built, from whether you're going to take it out of a capacitor or a battery or any voltage source, there's the ground, and then there's the positive charge of what it is. And all that ever happens, just like we see in the phenomenon of lightning, charge is trying to do nothing but resolve back to that point of rest we were talking about earlier in the paper, right? So for me, the electron that we observe is the resolution of charge, physically speaking, in space. That it's moving from one point in counter space, creating an arc, and then going back into another point of counter space. We are experiencing, witnessing, viewing, seeing the extinguishing of charge, that we only see electrons when they die, so to speak. That's kind of where I would leave that observation. So unfortunately, to a large extent, dealing with dielectric fields, the prehistoric conception of the electrostatic charge, the electron, on the conductor still exists, and by its use destroys the analogy between the two components of the electric field, the magnetic and the dielectric. This makes the consideration of the dielectric fields unnecessarily complicated, says Chucky Steinmetz, and I agree.
Dude, no
This
way he said that
vocabulary.
in the 1900s. That's hilarious.
The guy was the man.
Bro,
Totally.
after this video, after this reading, I got a video that we could watch on where the electric, or where it's stored, right? Because what they've been telling people is that it's stored in the metal surfaces, right? That's where the charge is.
Yeah.
So yeah,
They've been
I got a
talking
video on
about
this that we
pushing
could
water
watch.
through hoses forever.
Dude, it's
totally.
crazy.
No, it's all so physically bunk. Anyways, so finally we have this vocabulary of ether physics. Could be continued for several more pages. And with thank God he didn't, hey, we're up to 16. But let's wrap it up here with the concepts of time and space. As always, the best first step is to state what these are not. And nobody did that better than Poincaré. Time and space. It is not nature which imposes them upon us. It is we who impose them upon nature because we find them convenient. And he's totally correct. We just pulled down some nomenclature and applied it to the intangible, and everybody rolled with it. Time, like space, is the attributional byproduct of magnitude and its measure. which itself is a byproduct of magnetism, the divergent loss of inertia. A good way to visualize this is to think of the hands of a clock, second, minute, hour hands, as they measure out time. But at the fulcrum of these, at the center axle pin, time has no meaning. This immovable and dimensionless fulcrum of existence is the incommensurable ether from and around which the universe evolves and revolves.
Wow.
Here endeth the
Damn.
doc. Mic drop, yeah.
Yeah. Yo, thanks for grabbing that one, Stone. Holy cow.
I
see
couldn't
why-
resist. It was at
yeah,
the top of the
I see
list.
why you're
man.
like, how are we not gonna do this one?
Like, you say you guys were Aether Cosmology? Dude,
I was just
Dude.
checking.
dude, that is awesome. Thank
yeah,
you
that
for that.
was really awesome. Like, insanely awesome.
Cool. How about questions from the gallery? And what did you guys think?
Oh, man.
I guess I exhausted the topic.
Well, it was a lot we just went through.
Dude, yeah, there's so much more to learn. Is what I realized, right? Because it's like I half understand some of that, so it's like I'm gonna have to go back and spend some time on it and get more in depth on your boy
When you
Steinmetz.
do-
That's so funny that he said that about the
Oh, I love it.
storage in the 1900s.
No,
They were
Eric-
like, it's like everybody knew except for I don't know the people that wanted to believe in nonsense.
Except the mainstream. You got it. No, Eric Dollard quotes Steinmetz constantly. He is just the guy was just a wealth of knowledge about reality. The guy just threw down at every turn. So cool. But Alan, you mentioned you were going to go back and look at other things with this new context. And when you do, I would also invite you to keep in the back of your head what I said about dimension and how it
What did
relates
you say
to
about
space
dimension?
and counter space. Well, we started to count them. And we're talking about Cartesian analysis here for matter of convenience, this whole 90 degree by 90 degree by 90 degree Cartesian thing. And again, it reminds me of the flat earth arguments about how all the NASA docs for mathematical ease assume flat non-rotating earth because their math is just easier to work on like that. It's the same kind of thing here, that we've got the first three dimensions all 90 degreed up, and then there's time for number 4. And then we need 3 more for counter space. That puts you to 7. So if you go back and check these concepts again and you relate it to 7D space, counter space, 7-dimensionality, it'll make a lot more sense in terms of mechanism and which is operating on which side of time. That's what I would
Thank you.
say.
You know what? Yeah, thank you. There was a guy named Cyrus that came along it was a while ago, about a year ago, and was kind of touching on something similar about that, is how they had to mathematically represent those dimensions, which are like, where does the power come from, So I think that that's extremely helpful in that. Thank you.
Yeah, man. One other point about the previous paper, and who was reading it? Was it Flat was reading it? I
I think
think.
so.
The Einstein paper?
And it had, yeah, there was one comment about 80% of the way through that paper where it said we've got to observe and not accept the mainstream assertion how there is some limit to the amount of energy in counter space. Most provocative statement. And the mainstream will never even look in that direction.
That is quite provocative statement.
Yeah.
All right, I got a video queued up.
Cool, yeah.
So,
Yeah, do it.
I'm tuned
Do
in
it,
here.
man. Let's see it.
So this is a debunking of free electron theory by It's BS,
Cool.
and he's going to do a demonstration for us on where the charge is stored.
This guy's
The
awesome.
where to put it thing. You got it.
Yes.
Right on.
From a physics viewpoint, the energy of a capacitor is stored in the metal plates and not directly in the dielectric. As we energize the wires by using a power source such as this battery, notice that the two capacitor plates are accumulating charge. One is positive and one is negative. This creates an electrical imbalance between the two plates. Since the electron is a negatively charged particle, the negative plate is filling up with electrons. This leaves the positive plate in a position where it is continually giving up electrons. Now we can add a dielectric material in between these plates if we like, and that changes the electrical capacity that can be stored.
So real quick, any dielectric material is any non-metal pretty much.
More so, I would actually contradict this guy in about where to put it. And it is not stored in the plates. It's not about electrons entering and leaving the plates.
Well, I
Because
think
all
you
you're
keep
really
going
doing
over.
by saying that, he's quantifying how you are establishing a voltage measurement in how many electrons go in this direction or that direction, when really what's going on here, based on what we just read, is all about those down arrows in the space between the plates. That once the capacitance gets to a certain point, as in the voltage gets to a certain point, there is nowhere else to store it in counter space. It then arcs and resolves to the other plate. And that's why we put insulation in between.
Yep. Yeah, he's going over like the mainstream narrative of it before he shits on it.
Oh, I see. He's doing the illusion first.
Yeah, he steel mans, then he buys.
Oh, okay. I'll shut up
Yep.
then. Let him do it.
But if we remove the dielectric from this field, it should not have any charge on it, since the electric field is produced by the imbalance of this plate and this plate. So the real test of this free electron theory would be to remove the dielectric that's in this electric field, and then use that same dielectric and discharge it using two different metal plates. And now I'll take off the electrodes and then discharge the energy that's stored in this capacitor. Okay, now we're going to remove the top and bottom plate so there'll be no metal. Switch the jar over to a completely different set of plates. All new metal, and then we're going to discharge it. And this should show that the energy of a capacitor is stored in the dielectric and not in the metal. This is a screenshot of the capacitor discharge that we just saw. You can better see the corona discharge that happens inside the bottle. There are also small corona streamers that you can see coming up around the bottom of the container. And then the obvious discharge and the lighting of the lamp.
That apparatus
Another
is
device
so
I have
high-tech. Did you catch the
is
use
a
of a glue gun and PVC pipe?
Oh, dude, this dude's a G. It's hilarious.
It's hilarious. I love it.
Got him with a peanut butter jar, dog.
Is there
This
even
kid-
like a steel man on why that is the case?
No, they just no.
That's insane.
Dude, Steinmetz has been saying it since the 1900s. Hundies, bro. I just like this is crazy. Like Benjamin Franklin came up with this, right? This is a dissectable Leyden jar, right? So the thing is that you could charge it up, store it as configured right here. But you could also take it apart and then just take this jar and then hook it up to new plates, new everything, and everything that you charged it with originally will still be in the material and not in the
counter space.
Yeah, not in the plates. Yeah, dude, it's phenomenal, bro. They literally don't acknowledge it and just say that it's in the plates, and then like watch he goes through like a montage at the end. It's hilarious. But yeah, they've known about this forever. Big Benjamin Franklin figured this out in the 1700s.
Electroscope. So I built this one based upon his design, and what's great is it shows the polarity of these dielectrics after you charge them. You can see the positive side on the bottom.
More like positive and the most grounded point. This
And
is
the negative
this is
side
the
on
same
top.
thing as floating electric
This is
charge.
called a capacitor. Indeed, any two metal plates separated by some distance with stuff between or not could be called a condenser or a capacitor. Now this one, you see, can be taken apart. This goes inside and this goes outside, and I'm going to do some remarkable experiments. Now you watch what happens. Please. A little more. A little more. That's enough. Thank you. Now I am going to disassemble that. I'm going to take it apart. Watch how I do it. I have taken the innermost out, and I have taken the middle one out, And am I not connecting them all with abandon, right? Would you not think that if I ground this to this and this to this, that all the energy would be lost? Would you not think so? Yes, beginners think this. But watch now what happens. I'm going to assemble it. Watch, get in close, watch, watch. Do you see? The energy is still there. How do you like that, Father? Isn't that amazing? So the question arises, how is it that I can charge this Leyden jar, disassemble its parts, reassemble it, and still have the energy there?
Okay, it's now fully
That was
charged,
priceless.
and I take these
Oh.
insulated.
Dude, in the extended version of this video, it's 21 minutes. He plays like who's that guy from MIT that everyone likes? Walter
Feynman?
Lewin. No, Walter Lewin. Walter Lewin is proposing like free electron theory or whatever, like laying it out, the steelman of it, and like dude's video just completely refutes it. It's so funny. Maybe we'll play that clip at the end. Real.
Handles overcome the Coulomb force, and then oops! Obviously, there was never any charge on this metal at all. Oh, sure. The dielectric, no. The dielectric, we can take out of the capacitor. We can roll it up.
As a matter of fact, I'll touch both
Yeah,
plates.
both plates together. There's never was charge there. Okay.
Look at that.
Where'd you put it upside down? And if you got across both those, it would knock you across this room.
Now, we are going to check it. Okay, it was right at actually about 9 kV, okay?
Hey, that's Russ!
I gotta be careful. As long as I'm not grounded, I should be alright.
Oh, who's Russ?
That's Russ Grease, buddy I used to hang with a long time ago. RWG, see in the top left? That's Russ Grease Research. He did a lot of stuff with HHO back in the day. And he just kept moving on, technology to technology. The guy is passionate, let's just say that.
Awesome.
Right. So, watch this. Okay? Watch this. Okay? You can hear it's kind of staticky.
Yeah, you can hear it when he's pulling it off, playing with ambient.
It is staticky. It has a static type feel to it. Okay? Now I'm going to roll this up. This way, I guess. We can check our voltage. It is nothing. Okay? I can touch this. Nothing happens. Plate so it doesn't jump the
But when
gap
you
there.
apply the magic sauce...
Okay. Here we go. So it's sitting at about 8 kilovolt, something like that. So now we're going to discharge it. Okay, so we're just going to clamp ground on here. And we're basically going to discharge it. So here we go. Hear that spark? See that spark? Now I can touch it. No problem.
Okay, so is this the same guy that interviewed Tom Hutchinson multiple times?
I have no idea.
I never saw that. I don't think so. No, he lives out east. Hutchison used to live in New Westminster, outside of Vancouver.
Because he looks almost identical to another guy that interviewed Hutchinson. Okay.
Well, it might have been him. I just don't know about it.
This is like down my avenue of expertise, by the way, so I'm paying attention very, very closely. This is awesome, by the way, Stone. So keep it up.
Where's that Lewin part? 1 second. Looking for the Lewin part to wrap up.
It was right near the beginning there. Third block, second block. You can see him. Maybe I'm hallucinating.
Yeah, he's going
I
over
thought it was like
Benjamin
right at the
Franklin.
beginning.
No, I think it's right here. Nope. Yeah. This looks right. Because Lewin's talking about it. Okay, let's see,
Whatever.
let's see
Yeah,
what we
that's
got.
the man.
Before I start my experiment, I will give you some other examples of dissectable Leyden jar videos. The first video is by Professor Julius Sumner Miller. You can search by the title of the video and then move forward to the 10-minute mark. This is where the Leyden jar demonstration starts, and even though he doesn't explain how it works, he suggests that any student that can explain it should get an A. The next video is from MIT professor Walter Lewin. His demonstration starts at the 39:30 mark. So in this third video, Professor Lewin gives his explanation to what's going on. If you go to the 32-minute, 45-second mark in the video, he will justify his conclusion using math. And in my demonstrations, I will use different jar configurations to eliminate the theory that he suggests. And here are two videos that show the same test, except they use...
Yep. So the Steelman MIT professor explains it with mathematics that have no physical meaning to the demonstration. And that's it. That's not explainable. And that's why things are so screwed up. It just doesn't work the way they even say it does. That guy that did the experiment for those children that we watched on the Twitter short, that guy didn't explain it. He just abruptly ended it right after he showed the kids. Right? Like it goes
He
against what they
cited it.
teach.
He didn't explain it. Yeah.
Yeah, it goes directly against what they teach.
Sorry, I don't mean to interrupt again. I apologize. But what was the guy's name that I was just asking about?
I have no idea. The YouTube channel, the guy who made these videos?
Well, the guy that I was asking about that interviewed John Hutchinson.
I have no idea.
Oh, Russ Grease, you mean him?
Yep, that's him. He interviewed.
Yeah.
I got the
I
interview
knew
right
Russ years ago. He's pretty cool, man. He has a lot of adherence to scientific method. He does really well.
He does some really, really cool stuff. And I'll drop the link to that right now. He's in Hutchinson's lab, or one of them at least. So
cool.
Yeah, it's pretty cool stuff. I mean, this is down my avenue of like addiction. So,
nice.
Anyways, I'm sorry, guys.
You're straight, bro. Do you want to hear what Al Lewin explains this shindig?
Yeah. Absolutely.
Let's see what we got here.
I now want to revisit our Leyden jar. We had a truly absurd situation whereby we did an experiment with a jar, which you still see here, and I will redo the demonstration, but it's crying for an explanation because it looked like there was something wrong with physics. And I want to refresh your memory of what we have seen before.
It just looked like it. There wasn't. It just looked like it.
Dude, you see him, dude. He's clearing this chalkboard out, bro.
He's gonna crack those knuckles.
Yeah, dog. We're about to get an explanation, dude. Here we go.
Hold my beer.
And what this Leyden jar is all about. The Leyden jar is nothing but a capacitor, which is
you guys thought you seen physics get messed up? No, I got you, bro.
Of a bubble, a jar.
Yep.
So the inner portion, which is glass, say has this shape. You see it there. You're going to see it shortly there. And then we have conductors, a conducting beaker around it here.
How many chalkboards do you think it's going to take to explain this?
I'm hoping 3.
Yeah, 3 sounds like
I'm
a
hoping
pretty
at
good
least
guess.
3. He can definitely rotate that up and get another one.
And we have a conducting beaker on the inside. And we charge this up with the Wimhurst. This is the Wimhurst machine. And when we do that, we get free charge on the conductor. And so you get sigma free right here, and you get it here, opposite signs, of course. And you get sigma induced on the dielectric. Why do you get it? Because the dielectric sees an external field due to this sigma free. And so it begins to polarize, and so you get here induced charge, and you get there induced charge.
What the hell is sigma free?
Yeah, is he cheating?
What is that?
No. I think sigma free is like their free electron theory. Sigma
but
free.
I just meant with the charge
As in,
of the...
So he's positively charging the inside one is what he's trying to tell us? Is that it?
I think so. What? Sigma free electron. Oh, yeah, let's see. Free electron model. Let's see. Windhurst machine.
There's quantum again.
Yeah. Oh, yeah. We just learned a great deal about that tonight and how cool that is.
And immediately they start talking about charge carriers, and we talked about that.
You're looking for no sigmas on here. All right, but yeah, I assume that's just related to how they're describing the electron.
If this side is positive,
they call it free electron theory.
then the induced charge here will be negative.
Yeah.
And vice versa. we have here a metal hook so that we can lift out the inner portion. So what we did, we charged it up with the Wimhurst, and then there is a certain amount of energy. The electrostatic potential energy of this configuration is 1/2 Q free times the potential difference, and the Q free is the charge which is on the outer conductor. And what I then did, I disassembled it very carefully after we had charged it up, took the inner portion out, took the glass out, the outer portion, and I took all the free charge off. I touched the conductors and discharged.
You did, eh?
So there is no Q free left. It's gone. The moment that that is gone, the induced charge must also go away, because the induced charge is only there because of the free charge. Remember,
Look, the
the
math said
induced
so.
charge density is
Dude, it's only there because of the math equation I used to describe it. It said so.
1 minus 1 over kappa times sigma free. So if glass has a kappa of 5, then the induced surface charge density is about 0.8 times the free surface charge density. The moment that the free one goes, the induced one goes. And then I assembled it again, and much to our surprise, when I short out the inner portion with the outer portion, we saw a huge spark. That means there was energy left. And that is very puzzling. There cannot be any energy left unless there's something wrong with physics. So I first want to show that again to remind you
But
of what
how
you
long
have
did
seen
the
before.
spark last? See, this
And
is
then I will
the,
make
hold on a sec, man.
proposal.
Hold on. When he says there's energy left, you forgot about this thing Ampere pointed out. Remember that volt-second thing? That when we talk about current, it's about the voltage level over time to compute how much power, how much work is being done here. A massive discharge that is instantaneous. Really, he's just talking about how much was, I guess, what the total Q is in terms of what's being stuffed in a counter space when you charge it up. The two just, he's broken. The guy's broken. Anyways, go ahead.
Yep.
For an explanation.
Like he's about to repeat. I feel like it like troubles him to do this. You know.
No, I wasn't clear on that, but hopefully we will be by the end of this thing here.
Let me check my light configuration. Oh, we're going to make it all dark. I can charge it up while you're seeing it, actually. Yeah. Make it dark now.
So very high voltage, very
now I will
low
disassemble
capacitance.
I take the inner portion out. The glass is a good insulator, so I don't mind touching that with my hand.
Pesky copper.
Okay. And so now I take the inner conductor, touch it, lick it, kiss it, take all the charge off. There it is. Do the same with the outer conductor. Have it in my hand. For sure, there is no Q free left anymore, on that anymore. I put the glass back in again, and then I put the inner core again. And now I'll make it a little darker for you, because I want you to see that when I short this out, that you're going to see a spark. So I'm going to turn the light down. So look very closely. I'll tell you when I'm going to do it. 3, 2, 1, I'm approaching it now 0. And there's a huge spark. That means energy.
Oh,
that's crazy.
huge, dude.
There shouldn't be any.
Yeah, I mean, says him, right? Like I didn't see a huge spark, but
Well, we could hear it, but that's about it.
Professor said so.
And so some of you must have had sleepless nights not being able to explain this. Some of you actually wrote me email. You didn't have sleepless nights, I can tell that. So what's going on? There's only one possibility, and that is there must be free charge on the glass. How did it get there? Well, corona discharge. That's the only way it can get there. Keep in mind that the electric field in air, E in air, can be no larger than 3 times 10 to the 6 volts per meter. If it gets larger, you get corona discharge. In glass, by the way, it's a bit higher. It's 10 to the 7 volts per meter.
So he's talking about the minimum voltage before arc.
Yep.
I will now make some calculations based on certain assumptions. And those assumptions may not be exactly accurate because I don't know the exact
there's one
dimensions
down.
of this
Here we go.
system.
See, I knew it.
But the exact dimensions don't matter. What matters is the idea behind it. Why?
Oh, dog,
Get
you
that
just
big
pulled
ass
four
eraser
stock
out.
words at once.
So first of
Oh,
all, I
erase
will
that
assume
shit.
that this capacitor is just two parallel plane plates. That's a simplifying situation because it has the shape of a bottle. I will assume that the Wimshurst produces about 30 kilovolts. I know that it's approximately right, but it may be 25. It may be 35. I will assume that the air gap between the outer conductor and the glass is 1 millimeter.
guessing,
That
man.
both are 1 millimeter. And I will assume that the glass thickness is 3 millimeters. And I take kappa equals 5 for the glass. So that is the basis of my calculation.
Yeah, 3.
So now I have here the conductor on the outside. This is the glass, and this is the conductor on the inside. So this is 1 millimeter thick, this is 3 millimeter thick, and this is 1 millimeter thick. And the potential difference over the whole thing is going to be 30 kilovolts. But I know that the potential difference is always E times D. That holds for this gap, the local E times this D, the local E times this D, and the local E times that D. I also know that E glass is the same as E in the air divided by that kappa, which is 5. And I know that the total potential difference between here and here must be 30,000 volts. And
Well,
so
he
this
knows
allows
all
me
this,
now to
but he
calculate
didn't
in a
mathematically
very
prove
straightforward
any of
way
it.
the electric field here in the air.
Yeah, I was
Well,
going
he
to say
did
the
say-
same thing.
He did
He's
say he
not
was
proving
gonna,
shit.
Yeah, he did say he was going to solve this with a bunch of assumptions.
He keeps saying what we know, so nobody's going to argue.
Yeah. Dude,
Yeah, not
that's
very
why all-
rigorous here, huh?
That's why they all do it too, huh? They're like, we know science. Like, who told us that? Some guy at the chalkboard.
Well, it's on a
Everybody
whiteboard
knows that.
or a chalkboard.
The electric
that
field
must be
here in
real.
the
The chalkboard says.
air and the electric field in the glass, because I get a simple equation with one unknown. And that's the following. I first go over this gap, and so I get E in the air times that distance, D, which is 1 millimeter. But of course, later on, I have to go through this gap again, so I'll multiply it by 2 now. And now I have to add the electric field in the glass, which is the same as air divided by 5, times its distance, which is 3
Wow, this is
millimeters.
so algebraically
And that must now be
pedestrian. How does he get any
30,000,
of
because
that?
that's the potential difference between here and there. That's one equation with one unknown. And I can calculate the electric field in the air gap.
He can calculate.
And the electric
it,
field
okay?
in the air gap,
That's how he gets it.
So, Stone, is this dude trying to say that the initial discharge of it charges the air, which somehow recharges the apparatus? Is this what he's getting at here?
This is all about the argument of where to put it and where he thinks it's going and where he comes with this Q-free thing. And it's, I can't touch this. I'm sorry.
They don't know where to put the free Qs, bro. He discharged them all. And now
It's
they're
If I
now
was
he's
in his
gra-
class, I would have
now
walked
he's
out.
now he's grasping at straws. Look, he said, old girl emailed me and had a sleepless night over this because it completely refutes everything that we've been teaching. But don't worry, I'm gonna get these 3 chalkboards together and math it out for you guys based off of a bunch of assumptions. Like, dude, all right, dude. Well, okay.
turns out to be
No,
11.5.
Oh my, sorry to bug you there, but my question is like, where's his whip? I'm looking for his whip. I see all this equipment on the desks and stuff, but his approach is so draconian. He doesn't invite any question, any clarification from the class. He just says, we know this, it's got to be that, therefore it's this equation. Now we know that, and here we are again. Oh my
Yeah,
God.
or there's no background information whatsoever. You don't teach a class like this.
Yeah,
He's like on meth or something.
Yeah,
Yeah,
he's
nothing's
not
been-
educating.
Literally
This is
nothing
not
is
educating.
proven. Yeah, this is
Yeah,
dictating.
It's the only way to address this, right? Because this, without an authoritative, here's some math I've boldly asserted on 3 chalkboards, is the only way that you could, get these students to go have regular rest nights again. Right?
Well, the only way that this could be comprehensive to any student would be like, oh yeah, by the way, this is like your 3rd semester and it's the same exact subject. And we've already heard this before. This is just a review. But to me, this is not a review. This is like brand new information from a guy that's strung out on too much caffeine or meth. It's one of the two. I'm not really sure.
Yeah.
Times 10 to the 6 volts per meter. It's here the same, of course, 11.5 times 10 to the 6. And here, it is 5 times smaller. So I find here 2.3 times 10 to the 6. To show you that I did my homework correctly, the potential difference here is now 11.5 kilovolts. I put it here in kilovolts. The potential difference here is now about 7 kilovolts. And the potential difference here is the same, is 11.5 kilovolts. And if you add them up, you get 30.
I know where he gets that from.
If you look at this cannot be. Because a field of 11.5 times 10 to the 6 is way above the breakdown electric field. And so what's going to happen? You're going to get corona discharge from the conductor to the glass. And so what you're doing is you're spraying charge on the glass. And that's the key to the solution of this bizarre behavior. And so when you later disassemble it and you take the free charge of the conductors, there is still this free charge which you have sprayed on the glass. I never remove that. It's very hard to remove because the glass is an insulator. It's very difficult to take charge of an insulator. It's easy to take it off a conductor. But I never even attempted that because I made you believe, as I believe myself for years, that once you take the Q free of the conductor, that there can be no charge on the glass. That is wrong because there is corona discharge. So now
Yo, what the fuck, dog? Just said I made you guys all believe this until we came to a point where I had to teach you the truth and then come up with an ad hoc explanation of electron scattering. Dude, that's so disgusting.
I think he's snorting chalk dust right there, too.
Dude, he is. Oh, yeah, he sure is.
I told you, he's snorting something.
Yeah, he's snorting that chalk dust, brother.
I've never seen a professor that excited about something such nonsensical.
It's trying to sell him, dog. You gotta sell it. They told him
This
like
is MIT,
dude,
is that right?
Yeah. Yep. They're
Oh
like,
my
look, dog, we'll
goodness.
let you teach here at MIT.
Some of the smartest people, like students in the world, go there to listen to this fucking maniac.
Hey, he just said one of the most like if he had said that 10, 20 years ago, he wouldn't be a professor anymore. To say that an insulator is holding a charge.
Well, technically, that is possible. Anything can hold a charge.
That's what it appears that that's like.
But the way he's explaining it is completely nonsensical. And I've taken engineering courses with electrical engineering courses, and this doesn't make any sense to me at all.
So you're a teacher too, right? Have you ever ate chalk dust or anything like that? Or snorted it?
I mean, once in a while. But I'm mostly onto like the pens now because we're onto whiteboards. So I just
the markers. Oh, dude.
Yeah, I'm into the markers now. Yeah.
Yeah, marker stained lips. Okay, I respect that. All right. Well,
this is not medical advice. This is not medical advice.
Yeah,
I feel like don't do this at home. Don't do what this crazy professor's doing with the chalk.
Don't sniff it.
The question, before we disassemble, what now is the configuration?
He's like, God damn, that's a good hit of that chalk dust.
That's insane.
Of the electric fields and the potentials. I'll make a drawing here. And so now I draw again the conductor, the glass, and the conductor. I'd assume now that after the corona discharge, this field here is 3 times 10 to the 6. Maybe a little lower, but that's the maximum it can be. And so the field here in the air will be also 3 times 10 to the 6 volts per meter.
Oh, that's such lazy notation.
But since I know that the
So yeah, there we have it, folks. The original electrons spilling out just scattered onto the old glass there, and you can't discharge it because it's an insulator, and that's not what they were trying to do. So he just made everyone believe that physics was wrong for a little bit until he could mathematically explain it to everybody. Cool.
There you go. Thanks, Mr. Lewin.
Thanks, Lewin.
I would add to what he was talking about there about capacitance. There are two things they aren't explaining to us in the terms of the physicalities of where to put it, and we see it in the calculations they offer for stacked capacitors. For example, 3 set up in series. So the positive connected to the negative of the next one in chain, etc. So if you look at that even vertically in terms of charge, topmost would be the highest voltage on the stack and 0 volts at the bottom of the stack of the 3 caps end to end. You're making a totem pole kind of thing. Well, if those capacitors are all even capacitance values, like they all hold 20 microfarads, for example, then when you check the voltage of each capacitor as they are floating, they will show equal voltage. However, let's say that the top cap is 20 and the middle one is 10 and the bottom one is 20. The voltage across the 20 microfarad caps is going to be half each of the voltage across the 10 microfarad cap. That there's actually higher voltage being stored in terms of the total charge in the smaller cap. And I haven't heard any globies explain that one. You know what I mean? And I think that's what he's been doing here with the 2 conductors and the glass. That those he's talking about 3 places where technically capacitance could occur, except that only one of them is real.
Thank you for that breakdown. Yeah, because that was kind of crazy. Good old MIT.
Where to put it? The age-old
You might have
question.
to see that one in diagram form, but I'm hoping you guys get it.
Yeah, you completely lost me off the diagram, to be honest with you.
Smaller capacitance, higher local charge. That's about what that's about.
Oh, okay.
So he's just distributing it across 3 places where it's not distributed in that fashion, correct?
Yeah, it's not. This is not serial capacitance in the same context, and that's what he's doing. He's borrowing the mathematics from the other scenario and applying it to here.
Okay, I see. Okay,
Right?
so
He's
so the
pretending
analogy.
that there is capacitance in the conductive plate somewhere, and
Yeah, he just hijacked the math and just converted it into something different. Is what I'm gathering.
Classic, dude. So yeah, well, shout out to Lewin who got defeated by Benjamin Franklin in the 1700s. So very cool.
Cool. Yes, let's go ahead and wrap this one up then. That was awesome. Thanks everybody for reading. Thank you to Stone. Thank you to Flatless. Thank you to Quinn. Thank you, Alan. Thanks everyone for being here and listening. Thank you to New Perspective for showing us Michael Brenner's Quora page and all the wonderful Mike Brenner comps he put together. And of course, thank you to Mr. Michael Brenner, whoever you are. We would love to have you on at some point. I know we've got kind of a different time zone thing going on, but hopefully we can get it scheduled. Just let us know a time that works for you and we'll make it work. But yeah, so thanks again, everybody, for being here, and we'll see you tomorrow on Twitter Spaces and Tuesday for Shane's